happened.
I felt very awkward. I did. I was like, oh no.
Actually, the way I remember the story was just that she told you that.
Yeah.
And I knew how the two of them met. They were hiking together, and they just bumped into each other like that.
Oh, that's nice.
And, but I think you've exaggerated things just a mite.
Just a little bit.
Yeah.
It was kind of the facial expression, but that's kind of what she said.
Yeah. Hello, John. Hi, John. It's good to see you.
Well, also, I got everybody in front of me. There is something I'd like to bring up. The subject of constellation satellites. I know that's a dear subject to all of you. The other night I was out with binoculars, and I saw one about one a minute, maybe two a minute in binoculars the whole night. Well, for a couple of hours. I think we are at a juncture of amateur astronomy right now. As you can see, I'm kind of upset about this whole thing because I don't want to see satellites wherever I point my binoculars. And we've been talking about it for a couple of years now, and I can think, look, for myself, I think, well, we're there. And a lot of satellites, and there are not that many up there right now, actually, compared to the final tally. But it's something to get you all in the mood here.
It's also worrisome that they didn't end up damping the reflection the way they said they would. It's just,
well, the ones that I saw were seventh, I'd say seventh magnitude, although I did see a string of recently launched ones that were about 3.5 to fourth magnitude. But the ones through binoculars were really all 7.
John, when you get to see the string of the recently launched ones, and that's every couple of weeks, they're actually pretty beautiful to look at, as they look like this long meteoric string in the sky. And actually, I was inquiring, since I have to look at these damn satellites all the time.
Yeah.
If I could switch my internet to Starlink, but nobody's given me any pricing or anything, so I guess I'm not.
We have a guy here at Explore Scientific that's got the Starlink that you can roam with your RV. And he says it works pretty darn good. So,
Yeah, but what is he spending on it? That's the thing that I need to know.
As I recall, he's spending for that system, which allows you to move around. It costs more than the average. I think the average cost is about $100 a month.
Yeah.
That's what I think it is. This isn't horrible. It's not in the cheap range, but not horrible. But to move around and have those kinds of internet speeds is really remarkable. So.
Well, it might be remarkable, but philosophically, everybody, whether you're on the Starlink system or not, sees these satellites.
Yeah.
Even if you're
That's very true.
in Mongolia or the Amazon jungles or someplace in the Pacific, everybody sees them, whether you're a member of Elon Musk's Starlink or not.
Well, I think we can only expect, John, that we're going to see other countries.
Oh yeah.
And other providers doing this, so.
Well, that's kind of what I say. We're at the juncture right now in which we're seeing the end of amateur astronomy as we have come to know it.
Well, with all due respect, John, it does. We get a lot of the satellites in the first 90 minutes of the night and the last 90 minutes of the night. Right.
And in the summer, pretty much the whole night, though.
That's true. But in the rest of the night, when it's not in the summertime, you can see them all in the north. But
Yeah.
the rest of the night, they kind of leave us alone a little bit. And I think we're going to manage. Somehow, we're still going to enjoy Saturn. And I'd like to, with all due respect, disagree that it's not the end of amateur astronomy. It's just, it kind of maybe
Well,
adds something to it in a way. But
It's-
we're stuck with
it's
it.
not the it's not the end of amateur astronomy, but it's the end of what we have come to know it. And
Yeah, we're the start of something a little bit.
That's true.
yeah, well,
You
we'll
know, it's
see.
kind of
But
like
I think-
it's kind of like when we got the computerized mounts and trackers. Everybody
Yeah.
said that was the end of amateur
astronomy.
because wouldn't
Yeah,
know the
I
night
remember
sky
that.
anymore. The computers would do
Mhm.
everything. But we've adapted and changed our definition of what is amateur astronomy. And so I think it's going to be a question of figuring out what the next leap is to adjust the way in which we approach the night sky.
Yeah. There is a guy that is making masking software that uses an algorithm to look for satellite streaks on images, and it masks them out automatically. And so, you know, for astrophotographers, I think it's going to be manageable, even for the professionals. In
Perhaps.
fact, that's what it's being developed for, is professional observatories. Those kinds of programs usually trickle down to the amateur world, and then, you know, somebody will tweak those. So, yeah, but when you're looking, yeah, and you see something moving in the field, you know, a lot of people are going to think they're UAPs or UFOs or something, but, you know. So, yeah. Well, I think we should go ahead and get started here, folks. Thank you. Thanks, everyone, for joining us in the audience. We've got people watching from around the country right now, maybe actually around the world. We have some people watching from Argentina. So thanks for coming on to the Global Star Party.
In the past 20 years, cosmology has undergone a transition towards precision science. The standard cosmological model has been established, and its parameters are being measured with accuracy. Euclid will improve this model's precision and help us unveil the dark universe by studying the large-scale distribution of galaxies and cosmic structures. At 1.5 million kilometers from Earth, we witness the stars in the Milky Way, our galaxy, observed by Gaia. Euclid will impose highly stringent constraints on the cosmological model that governs our universe. Euclid will generate images in the visible and infrared, covering 1/3 of the sky. We have created the largest and most comprehensive virtual galaxy catalog to date. We're going to fly through our simulated universe. This is the simulated dark matter distribution. We note it is not randomly distributed, but rather forms clusters, filaments, and voids in between. Galaxies are tracers of the dark matter distribution. In this visualization, they are shown with fake colors depending on some of their properties. Note how different types of galaxies trace the underlying dark matter distribution. There are different types of galaxies. They can be red, green, blue. Euclid's flagship simulation allows us to visualize the universe from different points of view, giving us a better understanding of the evolution of the formation of structure in our universe over time. We have reached the limit of our simulation. However, this does not imply that these galaxies do not exist. Euclid will explore even further than our simulated universe. We have observed the universe from Earth, from space. Euclid's flagship simulation brings the dark universe to life, blending observations with our best theoretical model of the dark universe. Join Euclid on this extraordinary journey to unlock the mysteries of the universe.
Hello, everyone. This is Scott Roberts from Explore Scientific and the Explorer Alliance, and you're watching the 127th Global Star Party with our theme of exploring the cosmic tapestry. Our cosmic journey is a testament to human curiosity, innovation, and determination. And as we continue our cosmic journey, one thing remains certain. We come to know ourselves better. And the universe, with all its mysteries and marvels, will forever inspire us. So I'm glad that you're here. We kick off the Global Star Party with David Levy. David, do you want to take it away?
Yes, I do. Thank you very, very, very much. I'm glad to be here exploring the cosmic tapestry. And I'm thinking about this wonderful choice and trying to connect it with the discussion that I had like a few seconds ago with John Goss of the Astronomical League. At the beginning of our little informal session, Scott Roberts gave us a little sense of some of the things that he said that he probably wishes he hadn't said. And that we thought that was extremely funny. John Goss came in and gave a very eloquent, extremely eloquent session explanation of why he's unhappy with the Starlink satellites that are blanketing our sky. And right away, without thinking, I jumped in and pulled a Scotty Roberts and came in with a lot of other arguments. And so now that we're starting, we have the whole group together. I need to take a lot of that back. I think John's argument about all the satellites is very, very good and very potent. And they are going to be a part of our night sky. And I agree with John that it's a little bit depressing that there's so many of it. All I was trying to say was that when they launch a new set and the whole thing looks like this meteor coming down that just doesn't end, and you put your telescope to it and you count the satellites, they look kind of pretty in a way. And so, John, when you get to talk about the Astronomical League, which I adore, I'm really going to look forward to that. And the cosmic tapestry to me is exactly what that movie was trying to explain just now. But it is also the romance, the feelings, the passion that you get when you're outside under the night sky. Whether it's with a space telescope, the Webb telescope, or whether you're just sitting on a lawn chair looking up and you see shooting stars, as I did 44 times a couple of weeks ago. For my poem today, I'm going back to Sarah Williams' extremely wonderful poem that she wrote around 1868. It's called The Old Astronomer to His People. And as you're listening to that, as I'm reading it, we might think about the cosmic tapestry and the role that has been played in that ever since Tycho Brahe sat down. And he said, "Reach me down, my Tycho Brahe. I would know him when we meet. When I share my later science, sitting humbly at his feet. He may know the law of all things, yet be ignorant of how. We are working to completion, working on from then to now. Pray remember that I leave you all my theory complete, lacking only certain data for your adding, as is meet. And remember, men will scorn it, 'tis original and true, and the obloquy and newness may fall bitterly from you. But my pupil, as my pupil, you have learned the worth of scorn. You have laughed with me at pity. We have joy to be forlorn. What for us are all distractions of men's fellowship and smiles? What for us the goddess pleasure with her meritorious smiles? And you may tell that German college that their honor comes too late, but they must not waste repentance on the grisly savant's fate. Though my soul may set in darkness, it will rise in perfect light. I have loved the stars too fondly to be fearful of the night. God bless you all. Thank you. And back to Scott.
Yeah, I love that. That's great, David. Thank you so much.
Thanks.
And I like the telescope you got sitting beside you there that looks like a huge Questar, you know?
It is. It's a small Questar. It's a regular Questar.
It looks like a 16-inch Questar.
So I just have it a little closer to the camera than usual.
It's awesome. Thank you, David. Thanks.
This is Cupid. Was given
Cupid.
to me in
Oh,
2001 or so by Wendy as an anniversary present.
oh, that's
I
great.
admire it. And I also remember the little contest we did with you, Scott, when I was having a star party.
Hmm.
And we had a ETX at low power and Cupid at low power. And Scotty said, which is better? And I said, it's a toss-up. And Scotty said, oh, come on. And I said, no, at low power, it's a toss-up. At high power, it may not be.
Yeah.
But the ETX
Questar's got
is
superb.
really,
Yeah. Great.
is really
optics.
wonderful.
Yeah.
I love that, but I'm glad I have my Cupid here.
Wonderful. Thank you, David. Thank you. Okay. All right. So it's been a while, but a good friend and someone that has shared so many wonderful insights with us on Global Star Party is Professor Karim Jaffer. And Karim is a professor at John Abbott College. He is an extreme astronomy outreach enthusiast, and we are always honored to have him on. And he's with us tonight, and so we're really, really happy. Karim, thanks for coming on to Global Star Party.
Thank you, Scott. I'm watching Maxi and Navin in the background and just
Waving.
I'm so happy to be back. It's been way too long.
You have a huge crowd here clapping,
That's right.
supporting from
Yeah,
here.
you have your
I
own
have
fan
to tell
club.
our Canadian friends that Lori Roche from our National EPO committee that I sit on, she's here in the background with us as well. I'm so glad that she's joined. I brought her on the GSPs almost 2 years ago now from the Dominion Astrophysical Observatory.
Oh, I remember. Yeah.
And so I'm hoping we can get her back from the DAO sometime soon to give us another chat and get them onto that wonderful historic observatories list.
Yes.
It's definitely a need. So thanks, Scott, and thanks for the invitation. I love getting the emails for the Global Star Parties. It's been frustrating that I haven't been able to join too often over the last, over the last 8 months or so. We did the Starmus Festival, we came back and we hit a lot of really good global star parties. And then things just kind of piled up and I wasn't able to free up Tuesday nights for a long time. So I'm hoping that I'll be able to attend a few more this time around.
We hope so too.
The topic today, it's funny because whenever Scott chooses his topics, I always feel like he has some sort of either a webcam or a spy satellite or something watching what I'm doing for my class, because it almost always seems to overlap with either the way I'm setting up a class or a specific topic I'm doing in the class. And he even chose the Euclid telescope for the video intro today, which is one of the things I'm going to chat about in a little bit. But for me, when it comes to exploring the cosmic tapestry, when it comes to the night sky, most of what I do is done through the eyes of either my family or my students or both. And that's why outreach is so important to me and why I try to stay as connected as I can to the RASC, to Explore Alliance, to the Astronomical League, my Space Oddities crew in the UK, the University of Lowbrows in Michigan, and of course the RASC Montreal Center and our global star parties here. I always start off with a land and sky acknowledgement. We are on unceded Indigenous lands here in Montreal, but more to the point, we share the night sky, we share the cosmic tapestry, not just ourselves, but with the First Nations and the Indigenous peoples here in North America and across the world, and with ancient cultures and what they've seen and how they acknowledge the night sky. And I always look to the moon as my starting point, or to the star stories of the constellations. The moon right now, we are approaching a second full moon in one calendar month, which colloquially we are calling a blue moon, even though that wasn't the original definition of a blue moon. And yesterday on Space Oddities, I went through the definition of what a blue moon is, what a second full moon is, and what the 13 moons of the lunar month in the First Nations represents. And what most of the First Nations tend to do is they acknowledge what's happening in nature with the names for the moons. So because August has 2 full moons, we tend to refer to both of these as either the sturgeon moon for settlers, or the berry ripening moon for the East Coast, or even the grain moon or the barley moon for some of the regions around the Great Lakes. But we're not quite at the full moon yet. We're at a waxing crescent. And we have the first quarter coming up in a couple of days, but the waxing crescent I got to share with a few students today after class because it was so beautifully up in the daytime sky that I decided I wanted to set up a telescope and show people that you can see it during the daytime as well. And I want to just drop this reminder that the moon isn't just something that you see, for half the year at sunset or half the month at sunset, and then you kind of wait for it to come around again. Watch it in the mornings when it's a waning moon. Watch it in the late afternoon, early evenings. Pull out binoculars, take a small telescope. Even though the sky is bright, there's still so much to see and so much to enjoy with the moon in our sky. Here in Montreal, we are focusing right now on getting prepared for eclipses. And we have 2 amazing eclipse events coming up. On October 14th, we have the annular eclipse that's going through the southwest of the US. We're going to get a partial view of that. And on April 8th of next year, we have the total solar eclipse coming up. And I have here a picture from our 2017 partial view of the eclipse. So we are running the events, and I'm going to share a few things for Montreal audience. And for those of you who aren't in Montreal, which is the majority of you, I apologize for not being able to do this stuff with you in person right now. Hopefully down the road, we'll get a chance to do it in person together. But we have about a 20% view on October 14th. So we will have a public event for the partial eclipse. And then on April 8th, we get totality for 76 seconds. So we are looking forward, and I have never seen totality before, so I cannot wait. And I'm really hoping for clear weather in Montreal for that day. This weekend, we have a family day at our local aviation museum, and we're going to be doing solar observing to talk about the eclipse, to talk about the sun and what the sun is doing. More on that in a few minutes. And we just launched our novice astronomy courses here in Montreal. We are offering basically an intro to astronomy as developed by the Royal Astronomical Society of Canada's centers from across the country have contributed to this set of curriculum. So we are doing an initial 6-session outing starting on October 16th. And there's more information available at our website. If you're in Montreal, please join us. We'd love to have you there with us. Now, I start every term with a big amount of information on the partnership that we have with the Royal Astronomical Society of Canada Montreal Centre and all the wonderful opportunities that are there for students who want to do more outside of class. But within class, what I try to do for my approach to astronomy is to share what's happening now, as current as possible, but grounded in everything we've learned through history, through ancient and indigenous cultures. And so our second class that's coming up on Thursday is going to be about ancient and indigenous astronomy. Today was all about setting the context for the course. And I thought today's topic of exploring the cosmic tapestry was perfect because when I talk about context, I'm talking about all the tools we have to enhance our understanding of what's happening locally in our Earth, Moon, Sun system, or just with Earth, looking within our solar system, and then looking beyond. So I wanted to share with our GSP audience a little bit of what's happening right now in astronomy so that you can keep up, you can watch the news feeds, the X or Twitter or whatever you want to call it now, or threads or whatever it is that you're following, or on Facebook, and follow the new things and the current things that change the way in which we understand our connection within the solar system or within the cosmos. So tomorrow morning, the Indian Chandrayaan-3 is supposed to attempt its landing of both its lunar lander as well as the rover that's within that lander. And I cannot wait to see that. We're actually streaming it live on Space Oddities tomorrow morning because it's afternoon British Standard Time and it's evening India time. Now, the Chandrayaan-1 is something that I talk about all the time because it was a double impact study of the moon. And what I love about Chandrayaan-3 is that not only does it have a laser spectrometer, it also has an X-ray spectrometer. So we're going to get a lot more information about the substructure of the surface of the moon where Chandrayaan-3 is going to be trying to land. The sun. The sun is a fascinating object at all times, whether it's in solar minima or solar maxima. It's wonderful to look at in all different wavelengths. But right now, what's really curious is the amount of solar activity that we are seeing on the sun. This is a picture of the sun taken a couple of days ago by Roger Hyman in Space Oddities, one of my colleagues there on the panel. But just today, using Eclipse glasses and a Samsung telephone, one of my students, Lucas Larino Perez, took this picture of the sun, and you can see evidently 4 really clear sunspots. And this was actually the double one plus another 3. So this was done just with very simple observing equipment, and you can track these sunspots and see how much more numerous they are than what we were anticipating at this point in the solar cycle. Now, there's recent information out that the solar cycle matches the behavior of storms on Neptune, which is incredible given how far away Neptune is, how little insolation Neptune actually receives. And so tracking these changes now, and then following what happens on Neptune over the next few years will enhance our understanding of this dynamic of the cloud structures on the ice giant Neptune. The James Webb Space Telescope, since it launched 13 months ago, has been just making us drool with the amount of information coming out of them. This is one of the first deep sky images from James Webb that I have here with the Hubble image of the same space in the background. But what I found incredible is just the other day, they published new images from NIRCam and from MIRI of the Ring Nebula, which is one of my favorite night sky targets. And you look and see the level of detail of the expansion of the clouds of gas given off by the dying star before it became a white dwarf at the center. And with this extra information, one of the things that has been determined is there is models that show that this structure could only have been created if that's a binary system at the heart of the Ring Nebula. Now, we already know the Southern Ring Nebula was a binary system, and it's given us a tremendous amount of information to sort through over the last year since those first images from Webb came out. Now we have a whole new planetary nebula to look through, look at our models of how planetary nebulae are formed, and try to make sure we understand the death of stars similar in size to our sun. See, linked it to the sun and its increased activity. But don't worry, we have 4 billion plus years to go before we have to worry about that.
There's some time.
The Euclid telescope that was talked about, I am so happy to see it completing its calibrations. As some of you know, it launched on July 1st. So now we're in our 3-month calibration stage. And at the end of that 3-month calibration stage, Euclid should be exploring the dark universe by looking at these clusters of galaxies like that video talked to us about. Keep that in the back of your mind, because I want to mention something else to you in a few moments. But first, I just want to remind people that there's missions to Venus being developed as well that will still give us more and more insight into our sister planet. The Europa Clipper mission next year, for those in the GSP who, like me, love the little tidbits that NASA puts together, you can put your name in a bottle on a microchip for the Europa Clipper. So go to go.nasa.gov/message in a bottle and put your name in. I put my class in immediately as soon as I saw this. So make sure to get your name going to Europa next year. There's private missions to space, which we can spend an entire GSP talking about at some point. Hint, hint, Scott, we might want to do that.
Okay.
And then we have our Earth observation satellites. Now, longtime watchers of the GSPs will remember that I did a couple of talks on Earth observation satellites and the way in which we use the data from these wonderful satellites. And I know John Goss was talking about the amount of satellites that we have up there and how they ruin our view, but some of them are so instrumental. And I'm not talking Starlink. I'm talking things like Geosat, Landsat, the RadarSat here in Canada. They allow us to track things like the wildfires on Maui or the wildfires currently approaching Yellowknife in the Northwest Territories here in Canada. And we are able to actually work on our emergency response based on the way in which things like the fires that you will burn in order to try to stop wildfires from spreading in a certain direction, how successful that is, where to drop the most water to try to ensure that populated spaces have enough time to evacuate. But there's so much more. And so I decided I wanted a few more things to talk to the students about before I ended this first class that I did with them today. And one of the big things is Ingenuity, because if you remember early on this summer, we lost communications with Ingenuity. And now not only are we back in communications, it completed its 55th flight, and it's now flown over 12 kilometers on the Mars surface in total. For those of us that were there when Percy was launched, when everything was being talked about, when Ingenuity did its first flight, and we said, yes, this is a success. We're 54 flights later, and we're still getting data, and we're still getting images like the shadow of Ingenuity on a completely new stretch of land on the Mars surface.
So cool.
We have the XRISM launch happening this Saturday. This is an X-ray satellite, and it's going to be studying the X-ray emissions from galaxy clusters. So now let's go back to the Euclid, which is going to be studying the gravitational interactions of these galaxy clusters. I cannot wait to see the data correlated between XRISM and Euclid to really pull out that high energetic behavior and how it links to those clusters of dark matter, and whether or not there's evidence of the way in which those dark matter clusters hold on or push apart some of the galaxy clusters that we see in the early universe. OSIRIS-REx. I was telling my students today, OSIRIS-REx launched in 2016, my first term teaching astronomy. I watched it arrive at Bennu. I watched it orbit Bennu and determine an entire characterization of the surface of Bennu. I got to see it sample asteroid Bennu, and in a month, we're going to get to samples coming back to Earth. And so it's a full circle of a full mission to asteroid Bennu that I've gotten to experience as an astronomy teacher. And then, of course, there's the Artemis II preparations. And we're really happy to see Jeremy, Victor, Reed, and Christina getting ready and getting into one of the sample Orion capsules to prepare for their mission and their launch next year. So there is so much coming up to help us to investigate not just our local backyard, but the cosmic tapestry as a whole. Thank you from the Montreal Center. Back to you, Scott.
Excellent. Thank you so much. This is great. Well, I'm going to take your challenge seriously, Karim, and we'll see if we can put together a whole show about all these planetary missions and satellites and stuff that are out there helping us understand our solar system, you know, so.
I think it's a perspective that's lost sometimes, is how valuable some of our satellites are
Oh, absolutely.
to the actual.
Yeah,
Yeah.
you know, getting from here to the next star party, if I didn't have a GPS system, I'd be in deep weeds sometimes. So.
We still are, but those are for other reasons.
But I do have a story about that too, but for another global star party. It's me, deep weeds, cows, and the Okie-Tex star party. Okay, so.
Thanks for having me, Scott. I appreciate it.
Take care. Thanks. Okay, so up next is Mr. John Goss, who you've heard so much about here this afternoon on the Global Star Party. He is with the Astronomical League. He has been with the Astronomical League for a long time. He has served 2 terms as president of the league. He's absolutely devoted to helping amateur astronomers everywhere and just newbies, beginners, everyone in the astronomical community. There's few people like him. I like him.
I heard
joke.
that.
Just a
I
joke.
caught that.
Okay.
I caught that.
No, John is a great guy, and we're so pleased and honored to have you on Global Star Party. Thank you.
Oh, well, thank you, Scott. Yeah, I don't want to go into what we were all talking before the program started, but we were talking about constellation satellites and the joy it's going to bring us all. But anyway, I was thinking about what to say tonight, and it occurred to me that, you know, I don't know if any of our members really have talked a whole lot about actual observing programs that the League offers. That's one of them. The more well-known things that the League is known for are many different observing programs. So when Scott came up with this topic tonight about the cosmic tapestry, I started thinking, how could I work that in? And I think I did. So I'd like to start on that right now, see what we can come up with. Good. Before I begin, though, I always have to give a plug for the Astronomical League. A lot of people don't know this, but ALCON next year, that's the Astronomical League annual convention, will be held in Kansas City on July 17th to the 20th. It'll be, right now it's still heavily under planning, but we're aiming to have a hybrid conference of both virtual and in-person activities. So hopefully we'll see how that works out. So that's all I can say, because that's all I know about it. So let's get on to something which I think you might like to think about. Scott led off our invitations to help out with this star party with a quote, his quote. And when I read it, I thought, you know, that's exactly kind of what I wanted to say. But he said the words already. So let's go ahead and use his about discovering what our cosmic journey is all about, where it takes us, where it started. In a way, sort of like the journey is more important than the destination. Of course, the destination is important, but that we shouldn't ignore the journey. That allowed me to start thinking a little bit about the history of astronomy and how it affects us all. The League has a program called the Galileo Observing Program, which I want to talk about, delve into tonight. It's a program meant for, I won't necessarily say beginners, but for people who want to get out under the stars fairly quickly, fairly easily, and use binoculars to see certain things in the sky. It turns out that today's binoculars, give a lot better view than what Galileo saw. So we have a program which kind of emulates what Galileo tried to do, or what he did way back in 1609, 1610, and so on, that people today could try their hand at. So we have something called In the Footsteps of Galileo. You know, up until that point in time, everything we saw or everything we knew about astronomy was gained through observations, unaided eye observations, rather careful, painstakingly done. But still, that's only so much you can do with that. But when he came along and he pointed the first telescope towards the heavens, or at least to study the heavens scientifically, that really changed things quite a bit. And things have been changing ever since. Telescopes, of course, have gotten bigger, better, more powerful. We see more things with them. We have huge ground-based observatories. We have big platforms in space, getting all types of fantastic stuff. Enough of that. So we'll go on and talk about this program, that the Galileo observing program, what it offers to you and everybody else. You know, it's a little bit of a history tossed in about what Galileo did and what we can see. These are some of the activities of this particular program. What the Astronomical League has is a number of observing programs, and each of them has a set of activities that you complete. And it helps you give focus on what you're going to see that night or in the morning or the upcoming nights or whatever. And it's all done with this particular program, all done with binoculars. My wife and I completed this, I don't know, 10 years ago with these binoculars right here. And there are certain activities in this which are really easy to do, and there are certain ones which are quite a bit more difficult. What you really need, a nice pair of binoculars, 10 by 50s, that's what I use. And it's almost essential that you have to have a sturdy mount to put these things on, because there are many observations which take, you have to have everything nice and steady. You have to, you're focusing all precisely sharp, so you can see some of these things. And I like to talk about a few of them. I don't want to run down all these right here. I think there's 11. There's actually 13, but you see the bottom two. Aurora, okay, that's always pretty neat. But supernova, well, I don't know if we're going to be seeing that, but you never know. Oh, you can always keep your fingers crossed about that. But there's a number of items on here which I want to talk about because they may seem to be hard, but they're not really. Got to have the right attitude. Let's talk about Venus. Now, I want to talk about Venus simply because tomorrow morning, maybe that's too soon, but in the next week, Venus will start making an appearance in the morning sky. I think half hour, 40 minutes before sunrise. And it's a good time to start tracking our sister planet. It is fairly close to the Earth, which means that it's at its largest angular size in the sky right now. So let me explain this chart here, because it's kind of confusing. Obviously, August 25th, the disk of Venus will be 5% illuminated, which means it's a really, really thin crescent. But because the planet is fairly close to the Earth in its orbit, it also has just about its largest angular diameter in the sky, which will be about 54 arc seconds. That's pretty small. Through a telescope, it's no big deal, but through a pair of 10 by 50 binoculars, it might be. So keep this in mind. If it's 54 arc seconds in diameter, if you magnify it 10 times with your binoculars, it has an apparent diameter of what I have, 540 seconds, which is about 9 arc minutes. Okay, well, how big is 9 arc minutes in the sky? Well, the full moon is about 30 arc minutes. So if it's 9 arc minutes, it's about a third the size of the apparent size of the full moon in the sky. So if you have your binoculars trained on Venus and they're on a nice sturdy mount and sharply focused, you ought to be able to see a really thin crescent. And as the days go on, Venus has passed Earth and it's moving farther away, so it's getting smaller in the sky. So it's going to be a little bit harder to see. But really, up until about, I think I have November 15th, you should be able to see some type of phase shape for Venus through 10 by 50 binoculars. Okay, that's one of the activities. Another activity is Saturn. Well, I'll tell you what, you're not going to be able to see the rings of Saturn with your binoculars, with 10 by 50 binoculars. But you will notice, again, if you have them mounted on a tripod and they're focused precisely, you will notice that Saturn does not appear star-like at all. In fact, it looks like a little bit elongated dot. And that elongation is due to its rings. That's the observation you can make. Let's move on. Neptune is another object, which is one of the requirements. Galileo, in a sense, he never observed Neptune, but in a sense he did, because unknowingly, by a really strange cosmic coincidence, Neptune was in the same field of view when he studied Jupiter and its Galilean moons in 1612 and 1613. Just by a weird coincidence, there was Jupiter, but Neptune was quite a bit farther behind it. So in a sense, he did see it, although he may not have known the significance of it all. But just think about it, it was something like, if he would have realized this, he would have discovered Neptune 240 years before it was really discovered. So that's pretty cool. But anyway, one of the things is try to find Neptune in binoculars. You have to have a good star map to know exactly where it is, which I have something right here, which I'll show you how to find it throughout the next few months. So you can check that off your list. You've identified Neptune, although you might not know what it was, but you identified it. The sun, the sun's going to be a big deal this year, or in the next 12 months or so. But Galileo, as you know, observed the sun, much to his detriment, because he didn't realize about all the damage he was doing to his eyes. He didn't have any of the fancy filters that we have today. He didn't know much about how to do projection and things like that. So, he looked at the sun, and he did see sunspots, showing that the face of the sun was not perfect, as many philosophers of the day always said, the sun is perfect. Well, no, it has spots at times on it. So we have a requirement to look at the sun, but only under safe conditions. You can use special binoculars, solar binoculars, which have a built-in filter, or you can always purchase these handy filters which fit over the front lens of the binoculars. And let's see if I get this up there. And of course, you got to have two of them, one for each lens. That's what I use. This year, you'll be seeing all these all around the Eclipse glasses. No magnification here, but large sunspots, as Karim was saying earlier, you can see large sunspots with it. Shouldn't say with the unaided eye, but with the filtered unaided eye, you can certainly see them. Another way of doing it is by making a pinhole box. The problem with this is that the image that it gives is fairly faint. But if you do it right, you ought to be able to see large sunspots on the face of the sun. Essentially, it's kind of obvious what you do. You put a pinhole at one end of a box, pinhole being like the size of a pin, probably a little bit less than 1/16 of an inch in diameter. If the box is 3 feet or longer, it'll project a nice, maybe a 1/2 inch, maybe a larger image of the solar disk at the other end. And if it has large sunspots, you'll be able to see them as little dots on that disk. Another way of doing this, instead of using a box, is that you could use a fairly long length of PVC piping, maybe like a 4-inch pipe, and have a pinhole at one end, covering it at one end with a pinhole in it, and have that projected all the way down to the floor, and it might work for you. So keep this in mind. We never want people to look directly at the sun. You always have to have some type of filter, or use projection method like with the pinhole right here. One more, I think, do I? No, 2 more. A couple of our programs our activities for this program involve observing and drawing certain star clusters or certain features in the Milky Way galaxy. We have the Pleiades star cluster. You're supposed to draw that. M44, the Praesepe star cluster, do that one. There's also an interesting one called Orion's Head Nebula, which isn't a real nebula, but in 1610, before people knew what it was sort of a fuzzy spot in the sky at the head of the constellation Orion, just northwest of Betelgeuse. So he turned his spiffy new telescope at it, and he found out that no, it was a handful of stars all grouped together. Their combined glow kind of gave its fuzzy nature. On my drawing here, you can see that Galileo's depiction looks a lot like what the nebula, what these stars really do look like. I don't want to think bad about him, but he wasn't that good of an artist. But still, he came up with something fairly close. He could use a few lessons on this. But anyway, it shows you what you can do. And binoculars, this is nice to see. It's a pretty little grouping of stars. One more for you. Yes. He looked at the moon, and he has this, when he describes his activities, he wants you to know for sure that he was the first person to see this. So the way he words it about how, we all see these dark and white areas on the moon, but I saw these little spots, dark spots on the moon, lots of them all over. He describes it. But what the significance of this was, it was showing that the moon is not a perfect surface at all. In fact, it's more Earth-like than it is a perfect sphere. So we have in the program for you to observe the moon with binoculars to see if you can see some of the craters and draw the maria and see if you can picture any other features on the surface itself. Now, on the left-hand side of the screen here, this has nothing to do with Galileo, but I thought I'd end with this because not tomorrow night, on Thursday night, we have a nice lunar occultation of Antares. Depending on where you are in the United States, that depends what time it actually happens. For me, I live in Virginia, and I think it's at 10:42 p.m. was when it starts here, but it'll be other times at other spots in the United States. But that's something to look at too. With binoculars, you got them right here. That's all you really need. Aim your binoculars at the moon before the event happens, and just keep an eye on it. And it's interesting to watch the moon cross in front of a star or in front of anything, because it helps demonstrate that the moon really does move from west to east in its orbit around the Earth. That demonstrates that really, really well. And I give a website here. Just go to the International Occultation Timing Association webpage and look around there, and you'll find a list of cities and what times this thing starts, what times it ends. If you're in the Northeast, you're not really going to be able to see it. But if you're in the central part of the United States, you will, if it's clear, something to go out and look, because it doesn't happen at 3 a.m. in the morning. I guess 3 a.m. is always in the morning. Sorry. Doesn't happen at 3 a.m. It happens in the late evening. In fact, the closer you get to the Pacific coast, it's earlier and earlier in the evening. So it might be 7:30 by the time you reach Tucson, for instance. But it's something to have a look, and it's another activity and another purpose that you can use your binoculars for. And each time you do use these binoculars, and you're out there looking at these objects that Galileo saw in a sense, you are personally confronting history, because this happened 400 years ago, and it's still true today. The Pleiades still there, the M44, the Beehive cluster is still there, the moon. Moons of Jupiter, which is another activity, still there, Saturn, Neptune, so on. It's been there for people to enjoy and to ponder as they look through their instrument, whether it's a unaided eye or the binoculars or a really fancy telescope. I encourage people to go out with their binoculars. It takes you 30 seconds to unpack them and walk outside and start looking. Do that for a few minutes and go back inside and do whatever you want to do. But get out and observe under the stars. And that is it for me. I hope I push this enough for you to really want to go out. And you don't need much. Binoculars. Everybody has binoculars. Something to think about.
A question I
I
have, John.
appreciate that.
Yeah, thank you. Thank you. What is the observing guide cost? I mean, if you were to buy one to do the program, do you recall?
Well, on this particular program, there is no real guide. All the information you need is on our website. And
Oh, wow.
That's
Okay.
that's free. So yeah,
Great.
it tells you exactly what to do, where to go, all the steps you're supposed to take, and it helps you out with that. So
That's great. I
is
remember
a good
being
one.
at the last Alcon, and there were so many people there that had completed, so many of the programs, dozens of the programs. I think
Oh,
you
yeah.
have over 80 observing programs with the. Is that correct?
Yeah, I won't dispute that. There's so many I can't list them all. But
Yeah.
they're all. Oh, and if you're a member of the league, and if you complete this, you get a nifty pin.
Ooh,
Pretty
okay.
cool stuff.
That's cool.
Yeah.
If I could
Yes.
add something here. There are two magical organizations on this continent, and I'm sure there are others on other continents. But the two on this continent are what really get close to my heart. In Canada, it's the Royal Astronomical Society of Canada, and they are divided into centers in cities across the country. I began with the Montreal Center, and I'm still with them as my very favorite astronomy group, as Karim just noticed. And thanks, Karim. And it is more than magic to me to be involved with them. In the United States, the Astronomical League is as valuable and crucial to amateur astronomy in the United States as the RASC is in Canada. And it is very, very special group. I was just at the Baton Rouge conference. It was wonderful. There were lectures, there were dinners, there were informal chances to get together and get to meet the other people that are as passionate about the night sky as we are. But the league is something very special. And the idea of the synonymity between the Astronomical League and the major leagues in baseball is really not just a coincidence. Because in the United States, for those of us who have watched Field of Dreams, baseball is really magical to the history of this country. And on the same level, the Astronomical League is magical to the idea that thousands of people are passionate about the night sky. I suggest we all think about going to Kansas City next year. And I suggest that we all think about the Astronomical League, become more active with it, because it is a holy organization. It is wonderful. Thanks, John.
Oh, you're welcome. I don't know about us all going to Kansas City, because that would be 23,000. I'd be in a lot of
That's
trouble.
okay. They can handle that.
Why not?
But I have to say, if I can follow David's example there, I'm going to redefine my absence over the last few months as being on long-term injured reserve. And Scott, I want back pay.
Okay, no problem. I'll write you a check in the morning. All right. Well, that's great. We have, it's cool because on this Global Star Party, we have a lot of people returning back to presenting with us. And our next speaker is Jason Guenzel. Jason is a very talented astrophotographer. And Jason, are you with us?
I am here. Can you hear me?
I hear you.
I
Okay.
didn't
All right.
think
Let's
I was
bring you
next,
on.
but maybe you switched the
Great.
schedule at the last minute.
Yeah. Here we
Okay.
go. Jason,
Yeah, well,
great
thanks
to
for
see you again.
Yeah, it's good to see you too. It's been
Yeah.
a long time.
Yes, sir.
I think the last time I was on here was the 100th, so I've missed 27 of them. And you took quite a long break, so yeah, it's good to be back. For those who don't know me, my name is Jason Guenzel. I'm an astrophotographer, and got a little presentation I'll walk through today, just kind of on the basics of astrophotography. I've been involved in astrophotography in one shape or form for at least 10 years, by some counts, maybe 13, 14 years, but really enjoy it as a form of relaxation, and I love sharing it with people, and that's kind of my form of outreach. So I'll just this presentation I put together is just a general what astrophotography is all about, and it's geared towards a general audience. So I hope that we're not too general for the crowd here. But let me know when this comes through. Can you see it all right?
Yes.
All right, let me go into presentation mode. If you're not familiar with me, I introduced myself, but I also share a lot of my work on social media under the handle The Vast Reaches, so you can find me there. Also my website, www.thevastreaches.com. And what I do in general is just explore space from my suburban backyard. So I don't shoot from the most optimal conditions, and I've kind of honed my skills with that in mind. I've dealt with a lot of problems with gear and conditions, light pollution, etc. But pretty proud of the results that I've been able to achieve from my location, and this every slide on this presentation will have a picture we can talk about. There's a lot of words here, but I'm going to go kind of fast. So if you have any questions, you can stop me. But in general, astrophotography, what is it? It's just taking pictures of things that aren't of this earth. So we do this by using specialized equipment to take pictures of things that are tiny and faint and fuzzy, and reveal things that are otherwise hidden to the human eye. So why do I do it? Like I said, I find a deep relaxation of it, some form of reflection, or it's a nice escape from the crazy world that we live in. I've got a lot of curiosity about the natural world, the things I can find in my images, and I view it as a form of exploration. Every time I set up and take pictures, I'll dig into them to some extent, and look at things that are in the background that may have otherwise been overlooked. And as a result, found many interesting things and gone down a lot of rabbit holes. I started this back when I was around the age of 10. My parents gifted me a telescope. I still have it. That's a picture of it there. Last year I set it up, put the iPhone to the eyepiece, and just took a little video to show, yes, it still works. And actually the views are not terrible for a department store telescope that's probably around 40 years old. Around 2009, I got a little bit serious about photography and trying to shoot the night sky. So I bought this digital SLR camera you see here, the Canon Rebel T1i, and I used it quite extensively for the purpose. The pictures on the right are what I consider my first astro photos, where I just kind of pointed up at the sky and saw what I could do. So that's Venus and the crescent moon rising over northern Michigan, sunrise. And I probably shared these pictures here before, but I think this is a good, just kind of a good overview of what you can do with experience in this hobby. So both these pictures on the left and the right were taken with the same camera. It's just some of the gear has changed, and I would say 95% of what has changed is the technique and my ability to take the photographs that I collect and edit them, bring out details and reveal what's actually there. The technique is different, as I took a lot more exposure time in the one on the right, but you're looking at two shots of the Andromeda galaxy, one with just a camera and a lens pointed up at the sky, and the one on the right there is with a telescope on a tripod, and significantly longer exposure. It says at the bottom, 1.5 hours of exposure total. And so this is that same view magnified even further using an 8-inch SCT telescope. I love this shot because we are actually able to resolve individual blue supergiant stars within the Andromeda galaxy with just a consumer grade telescope.
Wow.
This is NGC 206 here in the center, and these are individual stars resolved within Andromeda. So at a glance, astrophotography, and all these pictures you see in the background, these are all ones that I've taken with my equipment from my backyard. I love taking shots of these galaxy clusters and looking deep into the universe. It's probably how I got my handle, the vast reaches, but just the sheer enormity of it and what we're able to see, you know, from any location on Earth, really, with the right technique. It's just amazing to me. So I kind of break down astrophotography into these three categories, and these are what I consider the pillars of amateur astrophotography. Now there's kind of two roads you can go down. You can do a more scientific path where you're looking purely at scientific data, or you can take creative photographs and process them to your taste, and be creative with how you shoot them, how you frame them, how you filter them, and how you edit them. So that's kind of what I do. And you can see here, I break it down into deep sky, planetary, and nightscape. So for deep sky astrophotography, it's amazing when you give a talk to a general group of people, the misunderstanding or the lack of understanding of actually how this is done. So I put this video together just to show two of my telescope systems, and then me manually controlling a tracking mount over on the right throughout the night here. And you can see the telescopes tracking the sky, and me looking super busy trying to shoot the Milky Way there. Once we collect all these photographs, we post-process them, and the essential pieces of gear really are just the telescope, the camera, and the tracking mount. But as I say at the end there, accessories. It's a money pit if you let it be a money pit, and there's a lot involved in getting a good result. But the more you dig in, the more you find the areas that need improvement, and the more gear you end up acquiring. I think every astrophotographer has a storage bin full of a nest of tangled cables and discarded toys. I will say that consistency is key in this whole endeavor, and if you can find a system that performs reliably and repeatably, you'll go a long way. So that's, you know, people are starting out, that's what I tell them to focus on, is really get something consistent that you can put out there and shoot and not have to worry about micromanaging it or being too hands-on with it. Obviously, you know, there's some people that are in it for, you know, the experience of being out there, more visual astronomy geared people, and they will want to be out there tinkering. For me, I know I want to do deep integrations, long integration times, so I set it up to run, and I want to be as hands-off as possible. And then with image editing, there's always the question of why do we need to do this? Well, the images as they come out of the camera are just black frames, and we shoot through multiple filters and handle these different images in different ways. And so there's a lot going on behind the scenes to generate the final image. Just to lay that out pictorially here, I say 65,536 shades of gray. Because these images are captured as 16-bit data, there's a lot hidden that is not discernible to the naked eye. And that's why a single 4-minute raw exposure there on the left is just a black frame. You see a couple pinpoints of light. That's what the photograph actually looks like. So if you want to know what, you know, if someone asks you what is the photo, what does it actually look like? That's what it actually looks like. Not very interesting, but if you stretch it, which is you take all the brightness levels and you expand that image so that all the contrast becomes visible, you get what you have in the middle there, which is that same shot just stretched. And if you stack up multiple of these and get a long exposure photograph put together, once you stack it, the shades of gray just expand and expand. So the deeper you go, the more faint detail you can see, and the more you can stretch the image to reveal those faint areas of nebulosity. So you can kind of see the progression here. And I've got this laid out in a video on the right-hand side, so you can kind of see the whole development process. It goes through capture, which you see here. And then I will show that single photo and then the overlay of the stretched. There's the single photo. I don't know if the video is playing smoothly for you guys, but this is the stretched video, stretched image, and then the stacked image. And then I combine multiple filters to create a full color image. So this was shot through a narrowband filter to get the detail, the luminance, and then shot through RGB filters to get more or less true color representation of the flaming star and Tadpoles Nebula. All right, so moving on. We're covering a lot of ground fast, so I'm sorry if there's questions. Let me know if you want to stop at any point, but I'll just hop through planetary real quick because it's kind of an entirely different discipline. We go from capturing faint detail on expansive fields of view to capturing the tiniest of details on bright objects. So we capture those in a little bit different way. We take video frames and stack up thousands of frames to reveal subtle details on these bright objects. On the right there, you see Venus shot in an expanded spectrum, near infrared, green, and ultraviolet. And shooting it that way allows us to see details in the cloud deck that aren't available visually. So that's an interesting way to present Venus. Planetary astrophotography requires different kind of setups too. For planetary, the aperture is king, so we can get detail on these objects by increasing the size of our optics, and normally that falls into the more reflector type of telescopes like Newtonians or SCTs. And long focal lengths are required, so we need to add Barlows or power mates to our cameras to get the image scale increase, to get a better image scale in the objects. So again, there's the planetary astrophotography is a lesson in attention to detail. So many things have to go right to enable the detail on the objects. You need to be using these large aperture telescopes that track well, get perfect focus and precise alignment of the optics or collimation. And then the wild card in the game is atmospheric stability or the seeing conditions. So all those kind of have to align, but every once in a while, even from a northern location like mine in Michigan, we can get some brief windows of stability and some pretty good outcomes. So this is Jupiter shot here with a 12-inch Newtonian telescope. And here's just a look at Saturn real time through that same telescope. And you can see here the wobble created by the atmospheric conditions. So that's why we take these, thousands of frames to capture the brief moments of stability and basically exclude everything that doesn't make the cut and stack up the best quality images. Here's a little pictorial view of that. So we get on the bottom there, we see the raw stack, which is somewhat blurry still because you're stacking up a wobbling image. But there's very good algorithms these days to sharpen the image. And then I shoot a monochrome camera, so I color combine it at the end. I shoot separate RGB frames to render the final image.
Beautiful.
And as a side adjunct to planetary astrophotography, there's also lunar and solar, which use similar techniques, although solar uses more dedicated equipment. And this is shot through my solar setup, which is an AR-152 telescope and a Daystar Quark. And Nightscape is a whole nother ball game, one I really enjoy, and that's the only one I do on location, not at the house, but I like getting out to these remote locations and shooting the beautiful night sky against the natural environment. I'd say it's probably the easiest entry into the hobby and requires only a basic star tracker and a camera like a DSLR or a mirrorless camera, something that many people have access to already.
Mm.
Still use long exposure techniques to eliminate noise. And because I'm shooting long exposures on a tracker, I need to do separate exposures for the sky and the ground. So this slide here just kind of walks through that, where I'll do tracked exposures for the sky. So this is 3 2-minute exposures for the sky to get that in crisp detail, then switch the tracker off and do the static ground at the same exposure level. And in post-processing, I'll combine those 2 images and then boost the contrast and the colors to get the final image you see over here on the right.
It is stunning, though.
So the common questions are, how do you get started doing something like this? And it's a discipline, and I underline discipline because it takes a certain type of person to get into this and doing it reliably to the level that you need to improve. Useful personality traits I put there: curious, inquisitive, patient, persistent, dedicated, adaptive. You can kind of see what I'm going for there. You need to have an analytical mind, and you need to be stubborn. But the key here is making mistakes, but understand those mistakes and realize what you need to do to improve. And so that's where the problem solving comes in. But as I said, it can be an expensive hobby. It doesn't have to be. You can start with things you may have access to, like a basic digital SLR camera, and take shots of the night sky and learn the basics of how to stack and process images. Those are the fundamental pillars of the hobby. And there's so many resources out there to learn, everything from having a mentor to looking online, YouTube, social media, astronomy clubs. Find the method that works for you to learn and just go after it. So for me, this is kind of wrapping it up here, but for me, it's science and art. So I love the science aspect of it. I'm an engineer. I love revealing these things in the image and learning about the nature of the universe. So the technology is just moving at blistering pace, but it's also an art, and it's a creative outlet for me to find ways to present these in interesting and new, fun ways. And so I've developed a unique style in my images, and I think they have a certain character about them. But I'll never stop, changing up and trying new things, and that's what makes it fun for me. So that's all I have here. I mean, I've got backup slides, but I went a little bit over time. So if there's any questions, let me know. But thanks for having me, Scott, and I hope you enjoyed the presentation.
Yeah, it's beautiful. The image that you had of Venus there was really incredible. It looked like you could start to see some surface detail on the planet. Could you talk about that a little bit more?
Well, it's not surface so much as the cloud deck you can see, but yeah,
Cloud detail
for sure. Okay. And especially in the ultraviolet band, which is a very challenging one to shoot because cameras aren't necessarily sensitive, and then ultraviolet and telescope optics are not optimized for ultraviolet. So it's a challenging band to shoot. But if you can find a telescope and a camera that works, you can see in the stacked image the cloud band detail. It takes
cool.
Good conditions. You have to shoot it at a certain time because Venus is, you only get a brief window to shoot Venus, either in the dawn or in the dusk.
Right.
So you got
not very high overhead. So
right, and you want it to be dark enough so it's not washed out. The contrast isn't washed out. So you got to find that little window where you can shoot it. But with the right equipment, yeah, you can definitely pick up the surface details. There are techniques also to get, cloud details. There are techniques to get surface details if you shoot with a deep, it's a near infrared filter, but around 1,000 to 1,050 nanometers, there's a brief window where the near infrared can peer through the cloud deck, and you can actually see some surface detail. So I've seen some amateurs do that. I've never tried it.
Right. Very interesting.
To,
There was a question too. What do you use to balance the colors? Are you using Photoshop?
There's a lot of techniques there, and it depends on what you're imaging. But for deep sky, PixInsight has some tools for photometric color calibration, so it uses known quantities in the field that you're shooting to balance the white and black point. So I generally use that when I'm shooting deep sky, but for the planets, especially if you're shooting through color filters, there's a little bit of adjustment to what looks right to the eye. And usually you're looking at an image, a known image, or an image that's acceptably correct to try to balance to that.
Mm-hmm.
I would like to make a comment, Jason, about the pictures that you took that showed the ground and the scene on the Earth as well as the night sky. As my grandfather would have said, they were excellent with a capital E and a capital T.
Yes.
And that I would, those pictures are Mozart. They are wonderful. Just wanted to say that.
Yeah, I really enjoy getting out and doing that. It's difficult though, to balance a life with going out to these remote locations. I mean, I don't get the opportunity very much. I try to take advantage of it when I do have the opportunity, but it's hard to get away from the light pollution for most people. People living out west are a lot more fortunate than people living east of the Mississippi, or I can't speak to other places in the world how accessible dark skies are, but in the US they're not very accessible around me.
Wonderful. Well, incredible work as always, Jason. So thank you again for coming on to Global Star Party.
Yeah, thanks for having me.
Thank you.
If anybody wants to find my work, you can find it there online, and I appreciate the time.
Okay, it is still at the Vast Reaches. Is that the
Yeah,
handle
that's
you look for?
on pretty much every platform. That's my handle, and then or you can go to my website and hop to it from there.
Great. Thank you so much, Jason.
Yeah, thank you.
Till next time. Thanks.
Yeah.
Okay. All right. So we are going back to. Let me find myself here. Here we go. We are going back to, I messed up the schedule a little bit, guys. But coming up next here, we're going down to Argentina to Maxi Falieres, who is a great astrophotographer as well. He's down, he gets some great Southern Hemisphere objects for us, often shooting live for us as well. And so Maxi, thanks for coming on to the 127th Global Star Party.
Hello, Scott. Thank you for inviting me. And do you hear me well?
Yes.
Because I was changing yesterday some things in the microphone.
Yeah, the audio and video is very good.
Excellent. So, well, I think that we cannot compare my picture from Jason Guenzel. It's almost too far away from professional for me. I only a newbie in this almost 5 years doing this hobby. But anyway, what I'm going to show you is what I've been doing last weekend, because we had a long weekend, but almost clouds there was. But in the Friday night, I saw there was a clear sky, and put my equipment outside. But first of all, sorry, was this. Like I showed you on the last GSP, I mounted this f6 8 inches on my mount. So I did the same thing, but before that I recollimate and also get some tube rings, because those that I got were from the F4 telescope, and it doesn't fit very well. So I try to make more easy when I have to change each telescope on the mount. So this is what I did. Here's the F4, prepare it, and here's the F5, the F6, sorry, with the two rings putting on. So it doesn't bother me. They have this, so I unscrew this clamps, I don't know, and put it again on the mounts. So that night I tried to capture the M23 nebula. This is with the F6, but I want to show you the comparison of the same camera, but with the F4 telescope, taking the same time of exposure. It was only 1 minute, 60 seconds. And you can see here is a quarter of this field of view. So basically it's outstanding for me because I always want to grab some details, and this is only a single picture. And if I go to one, I almost have a little of coma on the corners. So honestly, doesn't bother me if I want to do planetary nebulas and also galaxies, because here on the center, the stars are pretty much rounded. So for me, it's okay. And the difference here, if I go to one, we can, sorry, here and 1:1. This is the difference between each one of the field of view. Okay, so well, I stack this almost 80 pictures, and I get this. It's more sharpened. So when I process this, I only did a single process because I was working with planetary capturing. And then this is what I get for that night. And even the light pollution in my city, I could get these beautiful colors, these beautiful shapes. And the night, it wasn't a 5 points only. It was clear sky only. But anyway, I really love the spikes of these stars, the stars rounded, the colors of the stars, and the shapes of this nebula. They have these little antennas that I always want to capture. So, I really love to practice with this. And well, this is what I get from this sky imaging from that night. And then I tried to capture Saturn. That night it wasn't really good, but I did almost 45 minutes of videos of 22,000 frames per video, and I only stuck between the 2% or maybe the 5% of those videos frames. And each video it has 1.5 gigabytes of data, and I had almost 30. So I was talking with Nico because he helped me too much from the rotation and all this software stuff and the post-processing. And well, I was practicing and doing it again and see what I could do. And the result of that night, it was this one, for example. But I did again
That's
this
spectacular.
Thank you. You know, I was searching these results, and even the night it wasn't really good. I could get a lot of details on the rings and the shape of the surface and the colors. So I reprocessed this, and what I get was almost this. You know, I put it in the different position because this is how you see it from the north hemisphere, but here we see it like this because the south is here. So basically it's pointed up from where I am. So well, this is what I've been doing. I'm still practicing. You know, I tried to do Jupiter more later, but you know, here in the southern hemisphere, we have it pretty low, and it's almost impossible to get some details. But Saturn is almost at the zenith here, and well, this is what I've been doing from this week. I hope I can continuing. I try to get from the the opposition that's going to be in a couple of days, and see the differences and see what I get doing with this equipment. So let's keep going for that.
Yeah, beautiful, beautiful. Yeah,
There-
that's really great. What would
if
you
I
give
could-
as far as tips to anybody just getting started in astrophotography, Maxi?
Well, basically, uh, when you start to do this, you expect to get a lot of results in a pretty short time. So
Hmm.
you try not to, you know, you have your little spark from inside you that say, go on, keep going, you can do it. But sometimes you maybe, oh no, I don't like this, or try to get a lot, but depends of the equipment that you have. But anyway, you have to remember that you are doing with maybe a modest equipment, or you have the chance that you start with everything. But that doesn't guarantee you that you're going to get that information that you want in that pretty short time. So like Jason says, you have to get a path on experiences and mistakes that will help you to take a base from your knowledge. So this is my little sorry, I don't know how to say it. Advice, sorry.
Yeah.
For those who
Sure.
want to start this.
Well,
And of course, yes,
Maxi,
David.
say something. There's something about your picture of Saturn that really gets to me. And I think all of us here tonight remember the first look we had of Saturn and its rings.
Oh, yeah.
Huygens would have felt no greater thrill than we do when we first get to see its magic. It's not just something that's absolutely magic. And while I have the floor, I was able to take my telescope and bring it back to being a 3.5-inch telescope.
Oh, yeah. I see that. It did shrink a little bit.
Nice work, Maxi.
Well, thank you.
Excellent.
I'm glad I'm glad to hear you, David, and I'm really grateful for your support and the support of everyone that's, you know, asked me something, or maybe wants to share some advice, or maybe they ask me some advice, and I'm a open book of my little knowledge to give.
Hmm. Thank you. That's great.
Thanks to you guys.
All right. Okay. So thanks again. And I expect to see even more amazing shots from Maxi and all the guys that come on to Global Star Party with their astrophotographs. I'm always transported, like David was expressing here, you know, and certainly Saturn, for many people, that is the tipping point. You see Saturn for the first time, and it almost looks like science fiction. I mean, you just can't believe it, you know. So, and I think Michael Carroll will agree with that. Michael, you are up next, and it's
Okay.
great to have you on. I've seen some paintings that you've done, some illustrations you've done with Saturn and many other planets, and you know, you transport us. And so thank you very much for all the great work you do.
Well, thanks for having me on. You know, to me, one of the planets that gets the shortest shrift is Mercury. It's a very difficult object, obviously. And Dave Eicher could not be here tonight, so I'm going to give a quick plug for his magazine, Astronomy, but this is also a plug for Mercury. I did an article this September issue on Mercury's hollows, if anybody is interested in taking a peek at that. My talk is a little bit brief tonight. Let me open up my keynote and share my screen. Okay, let's see if, okay. There we go. Okay, can you all see that?
Yes, sir.
All right, here we go then. Exploring the cosmic tapestry, or how I and others got into this in the first place. This will be a bit on the personal level because I've had some questions lately from folks. You know, the sky is something that I love, and I come to that honestly. My grandfather was a general in the Air Force and responsible at one time for the experimental aircraft. My dad was an engineer at what's now Lockheed Martin for 32 years. And he designed some of the very first designs for planetary probes. This is a cartoon he did making fun of all the instruments that they were planning on proposing to put on this Venus probe.
That is great.
The interesting thing is, as the probe was finally designed, they had more experiments on it than he had in his cartoon. So, but one night he took me into his bedroom and he scrounged around in his closet and dragged out some loose leaf pages from some old beat up magazine. I think it was Look. And in this magazine were these paintings that just blew me away. Paintings by Chesley Bonestell of the birth of the universe and the development of the Earth. Bonestell went on to paint a lot of images that in fact have inspired an entire generation of engineers. If you talk to anyone on the Voyager project, for example, just about all of them will say that Bonestell is who got them into space exploration. So wondrous things that art can do for us. People have been, of course, depicting objects in the sky for a very long time. This is a series of drawings of Mars, and people like Lucien Rudeau took it to the next level. Rudeau was the director of the Meudon Observatory in Paris, France, and he was also an oil painter. He sat at the telescope and, without trying to jump to any conclusions, tried to paint exactly what he saw and what the science behind that indicated was going on. This is a painting of Mars seen from Deimos, and if you take the human vision of about 40 degrees field of view, Mars is just the right size in the sky for Deimos. He was very careful. Well, the next step was Dad bought us a telescope, my sister and me, and we stuck it in the backyard, and of course, in Colorado, usually the best things to see happen in the dead of winter. I don't know if all of you have experienced that, but it's very sad. I don't know why the cosmos works that way. But the first thing I wanted to see was Mars. Now, all of you with telescopes know what a mistake this is. Mars is not an easy object. It's a very difficult to see, and it was disappointing. But what was not was what we have just been talking about. I loved all this talk about Saturn, breathtaking in the telescope. Now, we can see cloud bands and moons and all those things from missions like Cassini, but seeing it in an eyepiece with your eye, you have a connection to that object. Looking at the sky live, there's nothing like it. And Saturn definitely was an inspiration to me. It was a heady time. The Soviets returned the first images from the surface of the moon in 1966. 2 years before that, year and a half about, Mariner 4 coasted by Mars and sent back 22 fuzzy images of the Martian surface. And it was a shock. People were not expecting craters, although there were some claims by some astronomers that they had seen craters along the terminator of Mars. But this made me get a little more serious, of course, about depicting things, and time went on, and I started to participate in studies of Mars settlements and various other things. And we began to learn in depth about how other planets worked. And one thing we figured out was that the obliquity of Mars, the tilt of the Martian axis, is pretty wild. It tips way over, and this has a tremendous impact on the Martian climate. This is one reason that we study the planets, comparative planetology. The changing climate of Mars has given us insights into climate change on Earth itself. And so this is very, very important axiom for planetary science. So the Viking and Mariner orbiters showed us hints of climate change on Mars, big dried out floodplains and things. And the theory in about 1976 to 8 was that Mars's climate would begin to warm again. Water would come up from the inside, the climate would completely change, and if there was any dormant life, it would come back. And so this is a painting I did of the Viking lander long in the future being used as nesting material by a Martian bird that has come back as Mars warmed up. Highly scientifically accurate, obviously. We have now, of course, seen Mars up close and personal on the surface with our beautiful rovers and landers, and we're able now to make a little bit better guess as to what some of the shifts, the changes in the history of Martian climate have brought. There's evidence of glaciation on Mars, of rock glaciers that may in fact be still active today. Obviously, there has been standing water. We can see it morphologically, but we can also see it chemically by some of the data coming back from the rovers. So it's very exciting to see where Mars has been. We're also, of course, learning about the outer solar system. Here is one of my favorite spots, Io, from Galileo, seen by the Galileo spacecraft. But we're learning more and more about the geology of other planets and moons. And so we can look at geology on the Earth and make some, draw some parallels. Here's a volcanic crater, Ubi-Hibi in Death Valley. And here is Io with Ubi-Hibi used as a caldera. Now, from Io, Jupiter is spectacular. if we take the painting as a normal typical 40-degree field of view to the human eye, Jupiter is 19.5 degrees. That is 38 full moons, 39 full moons across. Just spectacular. You wouldn't enjoy it for long. The radiation will kill you in a couple hours, but you would go out happy, I think. So I have had the privilege of painting lots of different things for NASA and magazines and books, and but it always points me back to the magnificence of the cosmos in all its splendor, all its glory. The cosmos calls us out of ourselves, and there is a spiritual dimension to it. For example, the Pillars of Creation is named after a sermon that was given in 1875 by Charles Spurgeon about how the power of the divine holds together and sculpts the universe. Beautiful, beautiful idea. So here we are, off to the ends of the universe as our travels take us not only across great distances, but across great spans of time. We now have really good images of the central hub of the Milky Way galaxy, enough that I can make a pretty good guess as to what it would look like from a nucleus of a comet passing by. But we see other things too, things deeper in space and time. The entire universe mapped across using cosmic rays and various other things, different spectra. And to me, this stuff all comes down to something quite interesting. There's something in science called Occam's razor. And basically what that says is if it waddles like a duck and quacks like a duck, it's probably not a kangaroo, it's probably a duck. Well, the universe seems to waddle as if it has been crafted. It quacks as if it is in delicate balance, in adjustment. And so we're left with wondering how that can be. And of course, there are many conclusions that can be drawn from that. People have been writing about it for thousands and thousands of years. Wherever you come down on the spectrum of spirituality, whether you're a skeptic or a person of faith, the universe calls us to look not only up and out, but also to look in. Where did we come from? What are we doing here? What is all this all about? These are questions that are great to ponder. It's good to look out and to look in, and the universe inspires us to do all those things. If you're interested in seeing a little more astronomical art, or if you are interested in becoming a space artist, I'd encourage you to drop by the International Association of Astronomical Arts, IAAA.org. And I love to talk about this stuff. There's a link to my email on my website at carrollspaceart.com. Love to have more conversations, scientific or spiritual. So hope you can stop by, and thank you, Scott, so much for the opportunity and to explore scientific. All right.
Thank you. That was very kind. Thank you very much. That's great. Well, we have a couple of eclipses coming. A lot of people
Scotty, if I
talking
could
about
interrupt for
them.
a second.
Sure.
To speak about what Michael has just brought up and the passion that he has for his astronomical art has just made me wanting to say that I believe this is by far the finest global star party I've ever been to. It is emotional, it is passionate, it's driving me even further into the night sky, and it's the best. Thank you, Scotty.
Wow, thank you. Thank you. There's been some great global star parties. And that's a big compliment. Thank you very much, David. Thank you. Well, okay, so we are going to talk to the person that heads up the Night Sky Network. And the Night Sky Network is an amazing organization that joins together, very similar to how the Astronomical League ties together so many clubs. The Night Sky Network also ties together so many amateur astronomers, but also they're woven into programs with NASA as well. And Vivian is, I can't think of a better person to lead that program. And she is with us tonight to talk about the eclipses and the Eclipse Ambassador program that Night Sky Network has. So Vivian, you got the stage.
Thanks so much for having me, y'all. It is so good to see your faces again. I see a lot of folks I just saw at the Astronomical League convention not that long ago. So what a treat to see you again. And David Levy, you inspired so many people at the Astronomical League convention. You made me cry a couple of times in your talk. Speaking of astronomical inspiration, that was just astounding. Thank you.
Thanks, Vivian.
I have no poetry tonight, but I just wanted to tell you a little bit about the Night Sky Network. Let me just share some screen here. I think I can do this for a slideshow. Let's see. I've been working at the Night Sky Network for almost 20 years now. Actually, sorry, no, 18 years. And the Night Sky Network, however, has been around for 20 this year. And we work with amateur astronomy clubs all across the US. We are NASA's connection to the amateur astronomy world. And I work for the Astronomical Society of the Pacific in San Francisco, California. I'm joining you from Berkeley this evening from my kitchen, where dinner is cooking, and I'm having a lovely time just listening to y'all. So I'll tell you a little bit about what we do, and I love questions. So Scott or anyone, please feel free to interrupt at any point, and I'll share some of what we're doing.
Sure.
My inspiration for loving on the night sky is I grew up in Nashville, Tennessee, and I was never expected to go to college. That was not my career path. I grew up with an amazing single mom who worked really hard to raise a couple of us. And when I got out of high school, just barely, I I went on and waited tables for a long time, and my only memory as a child of the night sky was in the car watching the moon follow us home, and thinking that it was following just us, like it was following us wherever we went, it seemed like, in the night sky. And it's so interesting. In my work today, I have heard that exact story from Tibetan monks on horseback riding through the Himalayas. I've heard that from people all over the world, that they thought the moon was following just them home as a kid. And I love that connecting thought that happens to kids all over the world, which surprises me. I eventually didn't have any kind of math, and I was reading about physics and astronomy, and thought, oh, I should probably go learn a little math, and went to community college and just took an algebra course and fell in love. Started taking physics courses and astronomy courses, and ended up getting a degree in astronomy from San Francisco State University here in San Francisco, but quite a bit later in life. And it has been the best decision I ever made. I would not have made that decision if I were going to college at 18. I would have definitely probably chosen archaeology, actually, which is another thing I really thought was interesting, but wasn't calling to me at the time. So I fell in love with the night sky for real when I joined an astronomy club while I was in college. And the San Francisco amateur astronomers were such an inspiration to me and took me under their wing. And I observed with them from many locations all over California, from Yosemite. They showed me dark skies, and I still to this day do not have my own telescope. I borrow telescopes from the Astronomical Society of the Pacific, who luckily has quite a few that I can borrow, and from the East Bay Astronomical Society and the San Francisco amateur astronomers. So luckily I love astronomy clubs because I get to try out all different kinds of telescopes. Many astronomy clubs have loaner programs. So if you are in an astronomy club or near one, I encourage you to check them out. So that's kind of my story of how I became inspired. And now I have what I think is the best job in the whole wide world. I get to work the Night Sky Network, which brings together astronomy clubs all across the US. Let's see, I'll tell you a little about them if this will, yeah. So just a little about the Night Sky Network. We, like I said, were established in 2004, and we have almost 400 astronomy clubs in the network all across the country. You can see about 11,000 amateur astronomers get our regular updates. And over the last 20 years, we've had almost 7 million visitors who the astronomy clubs have told us they have interacted with. We know this is a much smaller number than it actually is. We're estimating 10 to 20% we hear about, but we know that many clubs are using the Night Sky Network materials, and I'll tell you a little about what we offer. So we have these monthly astronomy webinars, and I encourage you, they are freely available on YouTube. I'll throw some links in the chat in a little bit. There's a couple of upcoming ones this week and next. I just put those on there because I thought about it. If you look up NASA Night Sky Network on YouTube, you can find us there, and there's a lot of upcoming webinars. We also have the clubs put up many, many events that they're holding. So if you were ever traveling somewhere in the US and you think, oh, I bet there's an astronomy club around, you're probably right. And also you might be able to find something an event coming up while you're traveling, which is really fun. This is also how a lot of the public are finding clubs these days. There are a few different lists out there, but because we have the clubs themselves update all of their events pretty regularly, it's a pretty good list of upcoming events that are happening around the world. We have, 15 to 20 events on there every day on average. So quite a few events if you're looking for things. Also has all the major star parties and things like that on there. If you want to add, we have a widget. Yeah, that's on there too. We also offer really good planner for anything that you plan to do in the night sky. This is especially good for folks who are new to astronomy, who are looking for what to look for in the night sky or how to engage everything from weather to let's see, what to look for this week, tonight, this month, and they're all kind of collected in one place. So that's one of our most popular parts of our website and is used quite a bit. We also have a monthly article that we put out. We have a lot of guest writers who come and write for us. This is an article that can be used in Astronomy Club newsletters. So you're welcome to use any of those. You can edit, copy, paste. It comes with pictures. It usually connects something that you see in the night sky with something that NASA is doing. It's kind of how we structure those, but something that's fairly easy to see for a beginner. And then we'll add in some telescopic treats as well in those. So those are some about what we do. We also support clubs. This was at NEAF. I was going to say, oh, do I have a picture of us just recently at the Astronomical League convention, but that was the one before. We support public engagement, and we really try to recognize public engagement as part of what makes an astronomy club. And many clubs have this in their charter, but when I first started doing amateur astronomy, it didn't feel like this was as valued as the observing piece of it, or as now as astrophotography. These are amazing images, but this piece about getting the word out to your community didn't seem like there was any way to kind of value and give some sort of recognition to the people who were doing this. So we created some different pins that you can get. The Astronomical League now has a great outreach program. I encourage you to also join that. We by no means are bogarting any of the pins, but we have pins that people are collecting. They show up to the Astronomical League convention, but their whole they have their Astronomical League pins on one side and all their Night Sky Network pins on the other side. And I am like the proudest person you could ever imagine. this kind of tells you, of course, during COVID, we took a hit because it kind of stopped. The public engagement for many places stopped. And then it got really creative. And I'm going to talk for a second about that. But first, maybe I can tell you about our newest program we have going on. This is the Eclipse Ambassador Program, and I'm really excited about this one. So for NASA to engage folks along for the eclipse, most of the work that's being done is, of course, on the path of totality. Even on the path of annularity, there's quite a lot going on. We have 2 eclipses coming up, and I'll show you some about those in a moment, that are going to be crisscrossing the US in the next 9 months, I believe. We're getting really close. But the Eclipse Ambassador Program is so exciting because this allows us to engage our communities before we skip town for the eclipses. So this is getting our communities prepared, because we all know, if you were watching eclipses in 2017, we all know that about a week before it happens, everybody calls you up. It's like, hey, what is this I hear about an eclipse? Right. And by that time, we are all like packing for the road, hopefully going somewhere exciting, or we have big plans with ourselves, our families, or even some of the clubs were staying behind and showing off during their telescopes during the partial phases. But this Eclipse Ambassadors Program is designed specifically to engage your community before the eclipses. So we partner amateur astronomers or eclipse enthusiasts of any stripe with undergraduate students. And this has to do with something that we've also been hearing in the amateur astronomy world about how to, we are graying as a community. I've been here for 20 years and I'm getting so gray already. We are, the amateur astronomy community is in general older and whiter and maler than the average population. And it's not because we're not welcoming. We are incredibly welcoming as a community. That is what brought me into amateur astronomy in my mid-20s. Just the kindness and helpfulness of the community. So we are trying to bring in some more younger faces into our favorite hobby. So this is part of that. So we partner eclipse enthusiasts with undergraduate students. We give you all the training you might need, give you all the glasses and activities that you can do, and we get you set up to reach out to your community before the eclipses. So I encourage you all, if you have any interest, it's not a heavy lift, and it's a really fun community of eclipse enthusiasts. So please join us. It's eclipseambassadors.org. It's easy to find. And we have a goal of reaching 1,000 people, signing up 1,000 people. We have about half of that currently. So we are looking for as many of you who are interested. We'd love to have you. You can go to, I'll also throw in the chat our link to the map where you can see if there's maybe an undergraduate near you who could use a partner who knows a little about eclipses and might want to mentor them. The amateur astronomers are also being mentored by the undergraduates. It's been a really cool experience to watch how they've been teaching each other about all the different things. A lot of the amateur astronomers are, for example, learning about, what it's like to be an undergraduate student. A lot of these students have just come out of COVID, so they don't have a lot of experience doing public engagement. And it's been pretty interesting to watch them get to experience the oohs and ahs of that for the first time. So it's pretty exciting. It's a pretty cool campaign. So I encourage you. I'm going to hop out of here and see if I can share. Is there anybody? Okay, go. And no questions yet. I was just going to show you some of the cool things that we did during the pandemic, because this is one of my favorites. So we put out toolkits for amateur astronomers. This is through the NASA Night Sky Network. And we put out toolkits that help you explain common things that you happen to be talking about tonight. For example, like all of the different filters that you're using, or the different ways in which we use filters to talk about light, and how we combine different filters to make different kinds of images. So this is a really fun one. And if you have your phone available, it's worth trying this out. It's not just for kids. When we do this in person, we have actual filters that you can see on the bottom left here. They're little handheld filters that you can look at these images with. But because we are not in person, I encourage you to take your phone. If you haven't used a QR code before, usually you can just hit your the camera and try and take a picture of this QR code. I'll give you just a minute to get started. This was part of a toolkit that we put out in 2020. Terrible timing for hands-on activities because we couldn't use them, but we made this virtual adaptation so that you could use it in presentations just like this one. So if I'll give you another maybe 30 seconds and tell you about the Big Astronomy project. This was one of our projects we did with the Night Sky Network, and this has to do with all of the big telescopes in Chile, and talks about how they use different kinds of light in order to get this amazing, the images that they get from these big telescopes. So is everybody ready? Anybody give me a thumbs up? You want to see? Did anybody get to download this? It's a pretty.
I got it. I got
Okay,
it.
just say yes to whatever it's asking.
Yes, yes, Vivian.
Yes, great. All right. So you might want to take your phone right now. You see these pictures right here, and we've got just a color wheel on the right. And on the left, we have the spectra of Vega. And we use those color wheels to talk about, you can just kind of take some time to explore. If you have filters, you can just do that too. If you have any of your filters for your eyepiece, you can use that. But
Cool.
on this, you can see what the different filters are doing. And this just kind of allows anyone to play around with what do filters do? And if I could see the chat, I would feel free to type things in or talk about what you're seeing when you use a red filter or a green filter or a blue filter. You can even just start with those, but then there's the extra one where you can get a little crazy. I would start with the red, green, and blue. All of these slides are available. I'll show you where to find them. And now, so we talk about here how filters can be used to decode the universe. So you try that red, green, and blue filter that you just pulled up on your phone and see if you
I
can
like that.
find the hidden message.
I'm not going to tell them.
Don't tell anyone. No,
Don't
no,
tell
no.
anybody.
Take your time. But so filters help us decode. They tell us about what's happening at different wavelengths. We can go into all sorts of detail there. So I don't think that I have.
Very neat.
Find it.
Interactive thing.
And then we talk about how we actually use different colors to representational colors when we have images that are taken in wavelengths that our eyes can't see. So this one here is taken in radio and infrared, optical, ultraviolet, X-ray, and we can see by using those filters which of these are being highlighted and how. There's a great website from I believe it's from NRAO, called Coloring the Universe. And don't quote me on that. I'll look it up when I'm done. That allows you to make these beautiful pictures from all the different wavelengths put together. So I think that was, oh yeah, oh, here it is, National Radio Astronomy Observatory. So it's just public.nrao.edu/color. Great, I'm glad I had that on there, but it allows you to kind of play with it like you would do. It's a very simple entry into some of the bigger concepts that you use when you're doing the astrophotography. And it's very fun to play with. You can make all sorts of different pictures, and they've got like the Whirlpool Galaxy. They've got lots of nebula that look pretty amazing. And I think this is from a larger, I'm just grabbing a bunch of different presentations I've given. Hold on, let me see. I was going to show you that because that was really fun.
Yeah, that was fun.
How much time do I have, Scott? You can cut me off at any point.
We are at 8:05 right now. We have been running a little bit behind, but
that's fine. I
what
can
you're
stop
showing is
there.
fascinating.
13 hours. You have 13 hours left.
Don't tempt me, David. I could talk all night. I just encourage you all to enjoy talking to the public, even if perhaps they're not as knowledgeable as you might hope. Oh, great. We've got lots of questions. So a lot of people are coming at astronomy from a place of curiosity, from a place of, we don't often teach astronomy in school, right? So a lot of people come to this on their own. And there's a lot of misconceptions out there. And there's a lot of, YouTube channels that are not actually real astronomy. So be gentle with the people who have heard many different things about astronomy, or who are excited about astrology even and don't know the difference, or come to you and think maybe they saw a UFO. They're coming to you with curiosity. I encourage you to really try and bring them into the fold, as opposed to making them feel really silly, because it's very easy to do when you do know as much as many of you know about astronomy. So I just want to put that plug in, because I really love to watch the curiosity bloom. And I think that we have this unique position to do that as amateur astronomers. So thanks, y'all. It's always a pleasure to see you here.
That is great advice. Any comments from our other presenters here?
Yeah, I have one as usual. This is actually my first acquaintance with the Astronomical Society of the Pacific in about 15 years, since I used to be on their board. But Vivian, you have helped capture the magic of why groups like the ASP are so important.
Yes.
But while I've got the floor, I'd like to say one other thing about Michael, which preceded your presentation. And he mentioned archaeology as being an interest of his. And if we go back into history, into the early part of the 20th century, Carlo Shapley was trying to figure out what career he wanted to take in college, and he had no idea. So he looked up everything in the calendar that Harvard had put out as to what courses they had. First thing he came up with is archaeology. Carlo could not pronounce it. So he went to the second thing, which was astronomy. And he said, okay, I can pronounce that. That's what I'm going to do. And I just thought I'd share that with you. But back to Vivian, I think the ASP is one of the great organizations in astronomy these days. And I understand it was founded for an eclipse of the sun that was in the United States in the late 19th century, and really grew up into the wonderful organization that it is today. Excellent presentation.
David, thank you so much. It is such a pleasure to work with y'all. Get to see you all the time.
Great. Okay. Well, thank you. Thanks again. It's a real honor to have you, Vivian. And, we encourage everybody out there to become an Eclipse ambassador, because this is your chance to get out there and really engage the general public in a very important way. So our next speaker is León García, and León has been on a couple of times. He is not new to astronomy and astrophysics, but I think he's really coming on the scene here for us as amateur astronomers and students of astronomy. And so, León, thank you very, very much for coming on to Global Star Party again. And I'm going to turn it over to you, man.
Well, thank you so much for having me back on. Before I begin my presentation, I'd just like to say these have been phenomenal presentations that I've seen today. And it's been really nice to see what everybody's put together. And Vivian, that was wonderful. And I'm definitely going to try and get involved with the Night Sky Network. And also for the earlier presentation that talked about putting the message in the bottle on the Europa Clipper, I went right to the website and put my name right in there so that I could be a small part of that. And I hope to convince you all tonight to join just one more scientific effort, or at least to have some interest in maybe something that you haven't seen before.
You are muted, León. There we go.
Okay, I'm sure. All right. So today I'm going to talk about a research group that I was a part of and have been a part of for the past 2 years, known as NANOGrav, or the North American Nanohertz Observatory for Gravitational Waves. But NANOGrav is a cooler and shorter name that stands in its place. And what NANOGrav's purpose is to form a galaxy-wide gravitational wave detector, or a pulsar timing array. And they work together with a bunch of other international organizations in order to do this on a global scale. And before I get into that, I'd like to talk about what a gravitational wave is first. A gravitational wave is one of the key predictions of Einstein's theory of general relativity, which is that space-time is not a stagnant thing. It's something that can ripple and be bent by objects that are massive and that accelerate rapidly, and produce imperfections in space-time, which propagate at the speed of light, much in the same way that light waves do, except they fundamentally disrupt the fabric of space as we know it. So they're really cool. And we know about a couple different things from our existing experiments that produce gravitational waves, not cosmic strings. That's more of a theoretical prediction, which I'll get to a little bit later, which are black hole binaries, which are these massive black holes that are inspiraling or circling each other until they merge. And then when they merge, they release immense amounts of gravitational waves in all directions. Inspiraling neutron stars, which are dead collapsed stars that are so dense that a teaspoon of their matter would be as heavy as Mount Everest and are only the size of the city. They collide together in some of the most massive explosions in the universe that are releasing more energy than the sun does in its entire lifetime in a matter of seconds. And these explosions are violent enough to create gravitational waves that reach across galaxies, and we're able to detect here on Earth. And these particular types of dead stars also have imperfections where when they rotate, some do so violently that they release gravitational waves in all directions. And finally, these cosmic strings are a prediction of our earliest theories of how the universe formed by inflating rapidly. And this caused potential breaks in the supersymmetry of space-time and create long lines of proton-sized matter that extend almost on galactic scales. And I noticed that there was some commotion out. And if somebody has a question, feel free to interrupt me during the presentation because I can't see the Zoom.
Okay.
But much like light, gravitational waves have different frequencies, and that's why we have a bunch of different experiments to kind of get at different parts of this gravitational wave spectrum. So we have terrestrial interferometers like LIGO, Virgo, and Kagra to get at low or higher frequency gravitational waves coming from neutron stars, supernovae, and merging black holes. We have space-based interferometers planned like LISA that are supposed to detect lower frequency gravitational waves. And that mission is going to go up in 2037, hopefully. And we also have ways of looking at the universe in its earliest stages, like the cosmic microwave background, to determine how gravitational waves interacted with one another in the early universe. And the talk today is about pulsar timing arrays, which is pointing radio telescopes up at very reliable cosmic clocks called pulsars that have a way of telling us if a gravitational wave has shifted the fabric of space-time in between us and them. The first of the experiments that I discussed was the LIGO-Virgo-Kagra collaboration. And basically what LIGO is it's a large-scale interferometer on Earth, which is physics speak for shooting a laser through a beam splitter down long tubes, bouncing the laser back and forth over 300 times, and determining if the space between the laser at the front or in this building and the mirror at the end has shifted in some very small way over the time that the laser took to travel down this vacuum tube. And this allows us to not only sense a gravitational wave, it also allows us to sense gravitational waves in the surroundings, which is one of the tasks of the engineers at these sites, is to eliminate background noise from many of the processes on Earth that create gravitational noise that disrupts these detectors. And we had the privilege at Alcon of visiting LIGO Livingston, where there's frequent logging operations in the area that cause rumbling that can affect the sensitivity of the gravitational wave detectors there.
Wow.
But these detectors are across the globe. There's one in Hanford, Washington, one in Louisiana, one in Pisa, Italy, and then one under a mountain in Japan. And there's also one planned for India using the same components that were used to build Hanford and Livingston. And that one's planned for a state in the west of India that would situate it perfectly to build a global network of gravitational wave detectors, where if you use them all in tandem operating at the same time, that allows us to have a better way of localizing on the sky where a gravitational wave signal is coming from. So if it passes through one detector slightly before another, it allows us to determine where on the Earth or on our sky that gravitational wave is coming from, which is really, really cool, and why we should constantly be investing in more gravitational wave infrastructure, because these things tell us a lot about how the universe formed that we weren't getting 40 years ago, or even 10 years ago, because the first gravitational wave detection from LIGO Hanford and Livingston was only back in about 2015, where there was a merger of two large black holes that was detected simultaneously and provided strong evidence in support of Einstein's theory of relativity. And that was over 100 years later, which is really cool in physics to have a theory that stands unproven for a very long time, and then 100 years later gets proven by an experiment, which
Cool.
cost billions of dollars to build. And I've had the privilege this summer of touring 2 out of 4 of Earth's gravitational wave detector. And it looks like I did it wearing the exact same shirt, so you can't really tell that it's in 2 different locations. But maybe I could wear this shirt to LIGO India when that opens up. But I did have a really great time viewing all of these really complex instruments that do various things to the beams of light that they shoot down the tubes to detect gravitational waves. And it's a really cool experience, and everybody, if they're in the area of one of these gravitational wave detectors, should go on one of the free tours that they offer to the public, because they're really great with their public outreach. And taking a little bit of time off Earth to our future space-based gravitational wave detector, LISA, we recently sent up a Pathfinder mission, or our initial kind of probe, to look at a location where we're planning on putting LISA, which is going to be basically LIGO, but with 3 arms arranged in a triangle over much longer distances. LIGO's arms each are about 2.5 kilometers to the midpoint, so 4 kilometers to 5 kilometers long, and these are millions of kilometers in scale. So they're able to detect a different frequency, a lower frequency of gravitational waves that pass through them. And this GIF at the left kind of shows how the warping of space-time would affect the laser's path, or the arrival time of the signals between these different observing stations that would allow us to detect both where a gravitational wave is coming from and that one has actually passed through the detector. And I think it's worth saying that this is a little bit of an exaggeration of what's going on, because space is many times stronger than steel. So it's very brittle, and gravitational waves are not as extreme as this is showing. But the mechanism that they're using to detect the gravitational wave in this planned mission is fundamentally the same as what they're doing at LIGO right now, which is shooting lasers and determining arrival times. And this this method can also be, or excuse me, I shouldn't get to that slide yet, but this method allows us to look at a different frequency of gravitational waves, and also this orbiter is going to be completely undisturbed of the gravitational waves that kind of influence our everyday life on Earth, like trucks passing nearby, ground-based detectors that could disrupt daily operations. And having it in the middle of space in Earth leading orbit at Lagrange point 1, which is basically a parking spot in space that allows it to orbit from a constant distance in front of Earth, allows us to have a more sensitive gravitational wave detector. And another way that we've been able to indirectly detect gravitational waves is by looking at the cosmic microwave background, which is leftover radiation from the Big Bang. And this radiation was shaped by many forces in the early universe, including dark matter, which I talked about in my last two talks on here. But it was also shaped by gravitational waves, which have contributed to the various shapes that we see in terms of uniform temperature and density when we look way back in space-time. And we can precisely determine the effects of gravitational waves by using these vector operations, which are kind of illustrated here, but are a little bit complex to go into in this particular talk. But when we point telescopes at this leftover radiation, we can actually really accurately determine the effects of gravitational waves in the early universe. And for more on that, you can look at this website. The Harvard Cosmic Microwave Background Group has great research on this particular effect of gravitational waves. And that's the cosmic microwave background is like using a universe-wide gravitational wave detector. And LISA is like using or the laser interferometer space antenna is like using kind of much greater than the length of a planet, and LIGO is like using a couple football fields worth of arm length. But what this presentation is about is pulsar timing arrays, which is using a galaxy-wide gravitational wave detector, which allows us to reach into the nanohertz frequency, which has a lot of really cool and interesting phenomena that we've been missing by solely focusing on other gravitational wave frequencies. And we build this gravitational wave detector that's as wide as our galaxy using these things called pulsars, which are collapsed dead stars that are so dense that that if you stood on their surface, you would be basically turned into a puddle by their gravity, not by their temperature. And they're only about the size of a city. They're formed but when supermassive stars collapse and push neutrons, protons, and electrons together to form this neutron-based matter. And they conserve angular momentum, meaning that they're a large, slowly rotating object that quickly collapses to a small, quickly rotating object, which allows them to rotate very quickly, and occasionally they emit beams of radio waves out from their magnetic north and south poles, which sweep across Earth and act like lighthouses or these cosmic clocks, which are incredibly accurate and precise, and allow us to both determine the location of the pulsar and keep a very detailed account of how space is shifting in between the pulsar and us. And we form arrays by discovering more and more of these pulsars and keeping accurate data on the arrival time of their pulses. So this allows us to lengthen our arms of our gravitational wave detector out onto galactic scale. And we use a bunch of radio telescopes, keep them pointed at these pulsars, and potentially discover more, which means that we have a lot of data, which I'll get to a little bit later, that needs to be sorted through by citizen scientists. And we add more pulsars to the array, keep accurate data, and we determine our observed versus expected arrival time of these pulses to get gradual ripple effects across our galaxy that can be attributed to gravitational waves. And those are computed by summing up all the residuals of the pulse arrival times and aggregating them so that we get a better picture of how space is moving. And NANOGrav is the North American section of that pulsar timing array. So each kind of section of the sky is reserved to a different collaboration. There's the European pulsar timing array, the Eurasian pulsar timing array, and several others across the world that each have their section of the sky and their radio telescopes pointed at their pulsars and gather data independently, share it with one another, and it can form a great picture of how our galaxy is having gravitational waves pass through. Is the North American version of that. It's funded by the NSF, and it has these 4 telescopes, now only 3 after the collapse of Arecibo Observatory, which gave us a lot of data, and it's very unfortunate that we're not able to keep it open. But this is the Chime Observatory in Canada, which is the newest of these 3 that are currently operational, the VLA in New Mexico, and the Green Bank 200-meter telescope in Green Bank, West Virginia. And the culmination of all of NANOGrav's efforts came this summer in the form of the 15-year data set, which is 15 years of data on 67 pulsars, which made massive strides towards a confident detection of gravitational wave background, which is basically if we're in a room and there's and I'm having a conversation with you that's more like LIGO and Lisa, what's being detected, but there's a lot of other conversations or murmurs that are going on in the background that we aren't able to tease out at our given wavelengths because we're not honed in on it. But we can ultimately hone in on it by looking at pulsar timing array in theory. However, we haven't quite reached the detection threshold, but we are gaining significant evidence from the 15-year data set. We're just a 0.3 sigma off from our desired detection threshold, which is 5 sigma or 5 standard deviations above the norm. So we are very close, but we still need more pulsars for the pulsar timing array and more data to make a definitive detection of this gravitational wave background, which would tell us about how the universe was behaving immediately after the Big Bang and the ripples that were produced from it, potentially isolate the effects of cosmic strings and rips in the fabric of intergalactic space that came with rapid inflation in the early universe, and mergers of supermassive black holes at the centers of galaxies, which are critical to the formation and evolution of the early universe, telling us how many galaxies were merging at a given stage of universal development. All of this we could learn from this stochastic background. And we can think of it like I have a lot of metaphors for this because this was covered a lot in the news recently, and it was described at great length for the general public, where LIGO is kind of like the violins in the orchestra. They get to play the melody, and Lisa will be the violists in the future, and the bass players are more like the background of all this. This is what we want to isolate, and these 3 and other phenomena, we can learn a lot from this background. And this made quite an impact in popular media. It was surprising to me how much this was picked up by major news outlets like the New York Times, Washington Post, and pretty much every other major news outlet earlier this summer. And they interviewed many of them interviewed two professors who are at the university in my town and who I've been involved with their group. And Jeff Hasboon and Javi Siemens, who both contributed immense amounts of their time and career to this entire effort. And it's been really great to see this pay off and what it's done for Oregon State, which hosted the Global NANOGrav conference earlier this year. And now you're probably wondering what you can do to get involved with this massive groundbreaking effort. And I'm happy to say that there's a lot of ways where you can sort pulsar timing data and also sort pulsar candidate data with just a little bit of training. You can get trained in access to large data sets where they're relatively easy to decipher. They just require pattern recognition and access to a computer and stable internet service. And the Pulsar Search Collaboratory is one example of this. There are others which are aiming at broadening access to this exciting new field of gravitational wave astronomy. And also there are NANOGrav chapters all across the US, and there are more opening up every day. So I welcome you all to look at these resources and to get involved with this effort. Thank you so much.
Thank you very much, León. That's great. Really fascinating. And quickly, what is that website again for the Pulsar?
The Pulsar Science Collaboratory.nanograv. I'll just drop it in the chat.
Yeah, drop it in the chat and I'll paste it into the. All right, León, thank you so much. We are going to move on to Daniel Barth, who's been waiting here with us. Daniel, thank you for coming on to Global Star Party tonight. You are.
Thank you, Scott. There you
There
go.
you go.
Anyway, thank you, León. Enjoyed it. Not to throw any shade on LIGO, my friend. I think you'll find the first person to prove distortion of space-time was in 1919. Arthur Eddington, the Eclipse expedition to the island of Principe, and he showed that the stars were actually out of position due to the sun's gravitation. But LIGO did it on the century mark, which was awesome. Anyway, I saw so much of my talk going by this evening, and people were talking about Saturn, and I'm hoping this is my notebook from a while back. And yes, I still go out and I sketch, and let's see, I had another one bookmarked here. Oh dear, I'll let that go. Anyway, I think about how I got started in astronomy. I was, like other people said, I was a boy of about 10. Didn't have a dad around at my house for a lot of my childhood, but my best friend's dad was the Episcopalian priest in town. And Father Bissett had a telescope, which I thought was just enormous. I saw it years later. My pal inherited it from his dad. It was one of these, I think it was a Tasco, and it was an F15 60 millimeter, 900 millimeter focal length, and an equatorial mount with a little wind-up clock drive. It was a 1960s special, and the glass was quite good. But when I saw that, I just started bugging Father Bissett. Can we try your telescope? Can we? And some of you know me, and you know 10-year-olds, picture me as a 10-year-old. I was a nightmare. And finally one night, the father said, yes, of course, let me call parents in the neighborhood and we'll go out. And it was a nice summer night. We went out in the yard by the rectory, and the moon was out. We looked at the moon, and I don't know, there were about 20 people there to start with. And about half an hour, it was me and Father. And we looked at the moon, we looked at different things. What's that yellow one? And he says, well, you can operate it now. I've shown you how. Go ahead and find it. And it was Saturn. And you set the hook. You set the hook for life. And my life changed entire that night. I didn't know it. As a kid, I didn't know it. He didn't know it. I told him about it years later when he was in his 90s. It made him very happy. But, you know, so many times we go out and somebody, I've often called any telescope as a party in a box. If you set it up where anybody can see it, people will wander over to you. And, you know, the first thing I ask is, what are you looking at? Can I have a go? And well, sure. Those interactions are never wasted. Never, never, never. And you throw that seed out and you have no idea if it's going to grow, if, when. And I've had thousands of people come through my classroom to take an astronomy class with me over the years. I've heard from some of those people, but I got to think that for a lot of people, I dropped a seed maybe that would come back and bloom for them later in life. So I want to just encourage everybody, continue with that outreach. Don't just set up your telescope, you know, in a lonely observatory, but sometimes take a small grab and go and, you know, go have a dinner at a bistro patio restaurant and then whip out your binocular on your tripod and look at the moon and draw a crowd. Because you never know. You never know that one little kid who needs a chair to stand on. Can I have a look? Sure. We'll get a chair for you. How does it look? The kid just goes, wow.
Yeah.
I've had students cry when I showed them Saturn. They wept because they realized I'm really seeing it and it's really there and it's that one and I'm seeing it and the rings are real. So go forth, my friends, and spread the joy. Okay, take your next time, sometime before the summer is over, take your telescope out where other people can get to you.
Yes.
You know,
Right.
don't be unsafe. Take a friend, but by all means, take your telescope out and just set it up on a street corner one day when you can see the moon. Set it up in a parking lot and have a go. Draw a crowd. Have some fun. Anyway, thanks everybody.
Thank you, Daniel. Thank you very much. All right. Our next speaker is Nicholas Arias. And Nico, you have got the stage here. Thank you for coming on to the 127th Global Star Party.
Hi, Scott. Hi, everyone. I was really missing that GSP nights, and I'm
Yes.
really happy to be back. And I was thinking about what Daniel says about Saturn, and I think that from the beginning of this GSP, we go on back with the Saturn observation changes. And everyone remembers the first time you observed Saturn on the telescope. Is stunning. Well, let me share my screen. Okay. Okay, is there?
Yes, sir.
Okay. Well, tonight I like to talk about what can I do? What can everyone do with when you have any telescope? In my case, I really enjoy and love making astronomy with a Dobsonian, and as I say, no tracked telescope, and I think that it's really amazing, not only for observation, but to think that what can I do that might be photography or planetary imaging or lunar imaging, but also you can do some science with any telescope. Not need to be a Dobsonian telescope. It could be an equatorial mount with no tracking, or with motors, or with any scope. But I center in what kind of things that I can do with my 10-inch Dobsonian, and I found that not only you can do some observation or imaging planets and lunar or the sun with the right filters, but you can do astrometry, as I talked many times about the double stars that I measure sometimes with asteroids, but also you can do some astrophotography, not at that kind of astrophotography with long exposures, because the obvious movement and rotation, but you can do a lot of astrophotography. And also I am making new tests on photometry with my Dobsonian. And I think that the most important thing is to know your setup, to try and make tests and go and to find the limits of your scope and the camera that you are using. For example, for astrometry or for photometry, you need to know about the focal length and the camera to know how much field of view you can use and how much exposure times you can do a very short exposures, but to find the right setup for getting the best results. And well, as I show in many presentations, I really love to do planetary imaging with my moving the scope with my hand. This is
Those are amazing.
a few planetary imaging from the few past weeks. You can see Saturn with Tethys, that little dot right there. Well, Jupiter, that here we have a very low altitude. It's really difficult to get some details this year, but I hope to get some good seeing night or mornings. And this is Venus a few weeks ago. And this particular image of Venus was taken on daylight, about 3 p.m. on the afternoon. It was very difficult to find it because I was blocking the sunlight with a wall in my yard. But this is one kind of thing that you can do with any scope, and you need no tracking. You keep recording videos and keep moving the setup, and then you can use a lot of free softwares to center the frames when the planet is in the screen, and you can stack and get this kind of images. Well, you can do, as I said before, some photography. This was using the SB Bony SB 305. That is a color camera, and this is all using the same technique that we can use for lunar or planetary, that is called lucky imaging. That is, you set up the camera in very short exposure times, maybe 100 milliseconds or 100.5, and you record a lot of images and then try to align and stack with. You can use today there is a lot of free software to do this alignment and stacking. And well, this was taken with the QHY5 camera. This is a monochromatic camera. You can see the small field of view because the focal length. This is a globular cluster, and the planetary nebula NGC 6818. This was all with the same technique, using really short exposures and stack maybe 300 or 400 frames to get this kind of images. And as I say, I was moving on how to do some photometry with good information on the images, and I found that with that short exposures in ShareCap you can do some live stacking. So this image is a 15 seconds live stacking with subs of 100 milliseconds. It's really short exposures, and this is the core of the galaxy NGC 6684 in Pavo constellation. And I was making some tests to see what kind of data I get from that live stack. And I found that you can do really nice measures for stars with magnitudes from 9 to maybe 14 magnitude. You can see this is a capture of the information of that star that using the sec plot, that is a free software to get the stars informations to make the comparison of the photometry. This green dot is that star, and I was using them to use like a calibration star for reference star. And I was making this kind of testing. I can get the magnitude with a little difference of magnitude, maybe decimal difference. And so this is a comparison star of 10th magnitude. And I make the successfully measure of the core of the galaxy. That was a magnitude of 12.3. You can see it's not a perfect, precise measure, but this is only one image on a random night. So I will keep looking how to make a better photometry with the Dobsonian. So what is next? I will start making my list of objectives, making my observational plans, and try to measure some eclipsing binaries, and I will return with the observation of asteroids. So to make a lot of the photometry, but that is a field that I do not do it a lot in that field, but you can. So this is the end of the presentation, and this is another thing that I found that you can do with the non-tracking Dobsonian.
That is absolutely awesome. You know, I think so many people are so inspired that you are able to do so much with the system, you know, and we recognize you as a master of being able to push your telescope and doing this. So there's some skill involved here, for sure.
It's really fun because you are working all the time with the scope. You are not
right
making the plan of capture.
Yeah,
and
you can't just run away. You got to be there all the time, right?
I really get fun with this, and that's the main idea, that to show everyone that no matter what is the scope that you can get, there is always something that you can do. So you need to learn and keep working.
Wonderful, wonderful. Well, as you get more into photometry and stuff, it'll be great to have, I think, a presentation just on that. So thank you so much.
That is my intent, to make progress on that and update this.
And I like your little logo here. Life's too short for small apertures.
Yes, so. That is. I will make a shirt for the next GSP.
Excellent. Okay,
Thank you,
that's
Scott.
great.
Thank you, everyone.
Thanks. Have a good night, Nico. Okay, our next speaker is Marcelo Souza. Marcelo is a professor of physics in Brazil, and he is also the editor of Skies Up magazine. It's great to have you on yet again. You've been on almost every Global Star Party, Marcelo. Thank you so much for being part of this one too.
Thank you very much for the invitation, Scott. It's a great pleasure to be here. Nice to meet all of you.
Thank you.
I'll talk now about the Brazilian constellations. Let me share my screen. If my computer work well today, everything, I can show everything. Here. Here is the image. I will begin with this image of our events, because here you can see the Southern Cross behind us.
Yeah.
And
Cool shot.
I will talk about this. How part of the Brazilian indigenous saw the constellations in the sky. Then here is the region where you have Scorpius, the Southern Cross, Centauro. Then in this region that they saw two different constellations here. But before I talk about them, I'll talk about the history. You have this person that was responsible for the first book that reports what the Brazilian Indians saw in the sky. And his name is a French priest, Claude d'Abbeville. He wrote this book, The History of the Mission of the Capuchin. I forgot here to put here in this screen. The History of the Mission of the Capuchin Fathers on the islands of Maranhão, que é Maranhão, a state here in Brazil, because the capital of Maranhão is an island and neighboring lands. And he talked with the indigenous that lived there, and he has made a catalog with 30 constellations. And I knew now this was in 1612, the first edition of the book. Then you have now a Brazilian physicist that his name is Germano Bruno Afonso. He is not more with us, but he came from his grandparents was indigenous, and then he returned the work to know more about the constellations from a part of the Brazilian indigenous. Most of them live in the south region of Brazil in his work. And then what they saw this. This is the most famous constellation from the Indians. What is the difference between what these indigenous saw and how that we see the constellations? Here is the Milky Way, and here near the Southern Cross, the Alpha of Southern Cross, you have the, I don't know how to say in English, in Portuguese, saco de carvão, something, a bag of coal. Is this something like
The
this?
coal sack.
Coal sack in English,
Coal
no?
sack. Yes.
Yes, the region that is dark here. They use the different brightness of the Milky Way to build the constellations in the sky. Then this region is the red of a bird, a big bird here in Brazil. That is the same like that you have in Australia. That is, we call Emma here. And the alpha and beta from Centaurus are eggs that this bird was eating. And the Scorpius here was the bottom part of the birds. And here is another Brazilian animal. I will show here that is easier with the Milky Way here. You see the red of this bird here in this region where you have the Southern Cross. I will return to the Southern Cross because we have a clock. You can use the Southern Cross as a clock, and I will show how that we use this. And I'm showing again. Here the region we have the Southern Cross, Alpha and Beta Centaurus. Here is the different regions of the Milky Way. Here Scorpius, and then this bird is here. Is a different way to see constellations in the sky that these Brazilian indigenous use. Here is also this region. You have Taurus here, the Pleiades, and here also they saw here, and the Pleiades here. But what is something that's different from us because they saw two constellations in this region, two different ones. Here is the bird, but I will show one that you have a history about this. At the same region, but here we have the Orion here, Taurus, Pleiades, and here is one of the most famous, that's the Old Man. Here they have a different history about him. I have here. The history is about this constellation represents a man whose wife was interested in his brother. To be with her brother-in-law, the wife of his man killed her husband, cutting off his leg. The gods took pity on her husband and turned him into a constellation. And here what you see here is that the Betelgeuse, that's a red star, is the region where she cut the leg of the man. That is the Old Man. And here the Pleiades is the bee's nest. Is a lot here. They saw a lot of bees here, where you have the bee, the Pleiades. That is ahead the red of the Old Man here. I have this is a better illustration what they saw. It's something different from what we see here. Different here you see Betelgeuse, Hegel. Hegel is part of something that the Old Man used to fight. That's not, they didn't draw here, but this is constellation. And here is Southern Cross. And a friend sent to me this yesterday, this clock that you can use, you can print and use the Southern Cross to know the time, the exact time. How that this work?
Very cool.
You have 3 parts here. This one you have the months. Here you have the hours. Then this circle here, you can see my mouse. No, you can see my mouse. I'll change it here to see if it's possible to show my mouse, but can you see my mouse? I will say yes. Okay. Here you have this second one, circle. You put it in front of this one, and this arrow here, you put in position the day and the month. And this one here, you put in front of this one, and here you have the line of the hours. You put this draw in the same position that you see the Southern Cross in the sky. Then is this here, like this. Here is in August, and then you put this one here in almost the same position of the Southern Cross, and here this line gives you the time. Then it's something very useful for us. And we are printing a lot of this to give to the students now. I received this yesterday, this different clock. And only in the beginning of the summer that will not work because you can't see the Southern Cross here in Brazil in the beginning of the summer. Then, but in almost all the year, you can use in the beginning of the night.
That's cool.
It's something different. And I show now a video that we record a member of our astronomy club during the night saw the sky with different colors. and you need to organize an investigation here to know what's happened. Let me see if you know what's happened here. I'm showing here the video. Is the entrance of the city. This was almost 3 a.m. in the morning. Here's the entrance of the city. You see the sky. We have this color 5 times. Have another time that you have the sky blue. Wait a moment, sir. You see again the sky blue.
Yeah.
Blue
Yes.
again.
Yes.
And we tried many things to understand what happened here. It's very difficult to be a meteor, but who knows, no? And we try to find an explanation for this, why the sky was so blue so many times, 5 times. Anyone know what happened? We know, now we know. Because the same thing happened in the United States, in New York. This that happened to us to understand what happened. And then we made an investigation and we have an official answer about what happened. And unfortunately, is not something from space. If you see in your city, I will share here a video. And I show my screen. I share my screen. You see what's happening. Okay, here. On a moment, I'm sharing my screen. Okay, I'll share the screen here. Is this what's happening? There's something curious. This is the reason that I'm showing. What happened that I can't. On a moment, because I don't know what's happening. Here, I found. Okay. Here. Can you see?
It's coming.
I'll move here. Jason. In New York happened the same thing. There was a transformer explosion in New York that did this. Here, then, when we saw this, we made contact with the power company of our city, and they said that it wasn't a transformer explosion, like what happened in New York, but it's something that happened with the power station here, that we have the same result here. You see the sky blue. What's happening here? It's not this, sorry. It's not this. They changed the video. Well, I don't know what happened. It's another video. But it was a power explosion. You can see this is in New York time. You only need to put in blue sky in New York. It's the same that you saw here. This is what I would like to show today. Thank you very much for the invitation.
Thank you very much. Thank you.
Sometimes what happened didn't come from the space.
That's true. Well, we're in space, right? I mean,
yeah.
Yes. It's still from space, I guess. So,
thank you.
Marcello, could you put into the chat a link where people could download the Southern Cross Finder?
Yes, I will, because it is in my email. I don't have it online.
Okay,
I don't
next
have it
time.
online. But since I have it online, I send to you the link.
Okay, sounds good.
Okay.
Thank you so much.
My pleasure to be here.
All right, so we are staying down in the Southern Hemisphere, and we are going to visit down in Argentina again. And I think we have Cesar. Cesar, did you get some clear skies?
No, because you can see the
Oh, it clouded up on you. Okay.
Fortunately, yes, I have something in the screen. Let me show you.
Okay.
A live image is ever live image is okay. It's something that let me put the image only to 1 second. It's much better maybe for centering. Let me check. Here is Antares. Are in.
We can see your screen sharing pretty good. Your
Yeah,
internet speed
yes.
is not real fast today, but the screen looks great.
Yes. You can see the image.
Yes.
I don't know why. Let me put again in the center because was tracking very well, you know, but now is a typical thing when you need that the things
when you need it to work. When you need it to work. I've been there many times.
Yes, yeah, sure. Let me use the yes. I first of all we can check. Yeah, okay. I'm centering again.
Maybe check the right ascension lock and make sure it's locked. It looks like
yes.
It's
the zone of M4. Yes. Now it's not tracking. I don't know why because I use a lot of different pictures and I took a lot of exposures of but now I don't know why.
Well, Nico has shown us that we don't need tracking.
Yes. Nico's make magic in her hands.
That's right.
But it's another. If for another, sure. It's for another. You know, it's for another world. Nico. He make something magical with their hands. Now it's tracking. Okay, and let me. Well, this is live. This is how the people use the telescope. I'm try center again because I don't know if I can put again the Antares star in the center, but we can try. Okay. Maybe yes. I'm moving the telescope. Maybe it's great this to show to the people, not for us that normally we use telescope. We know about the group of global that they suffered me many times with the things.
Yes, Cesar, it's freezing. The internet's freezing up here.
I'm freezing, but me or the telescope or the image?
You. The image is fine. And we lost him. Let's give it a couple of minutes and see if we can get him back here. He is back.
I lost Yes, I lost the connection now.
Yeah.
Oh my God. Okay.
It looks good now.
Okay, maybe you can see. Okay, you can see again.
We can see you and the telescope. Yes.
Okay, okay. I share screen again.
Okay.
And this is where I was when I lost the signal. I'm centering Antares now.
Okay.
Okay, it's working again.
Antares is one of the largest known stars. And
Yes.
it's several hundred times the diameter of the sun and 10,000 times brighter than the sun.
Look the quantity of stars.
There we go.
Yes, where each of one stars are suns, and look the difference between Antares. Of course, that you can see stars that are in a very high distance than Antares, but Antares have a huge size, and maybe one of these stars are in a similar distance. This is amazing. Tonight, where we are talking, we are thinking in this kind of scales and all about the how we enjoy it, and we are amazed by the cosmos. It's something that is magic. It's something that we I never stop to me to be amazed by my astronomical observation pictures. You know, it's something that is so great. It's so magic.
I think in this group here, in our audience, that you're in good company and in complete agreement with all of this. It is magic.
Yes, absolutely. I love this of in the city where we don't have the possibilities to have a great image at the night eye, this electronics, the cameras. Last week you told me that if I can explain the setup, the gears, and for the audience, I can see that here I have the cooled camera. It's the same the same sensor that you have in your reflex camera, in your cell phone, in the different size. But of course, this is for the audience, people that ask about the first day that he go to the store to ask about the telescopes. Many times, I told with the people that see the telescopes in the window, and when I start to talk with them about the possibilities that today do you have tonight? It's okay. Do you have that you can work with your small telescope from the city, from the rural, for the farm areas, clear, polluted skies, light polluted skies.
Yes.
Or clear sky, very dark skies, but you have many options how to make your setup for your telescope. Here, I use camera, telescope. The focal length of the telescope is a system of lenses, three lenses, apochromic a performing objective that make the image in the focal plane, and the important thing too is the mode that is tracking the movement of the sky, and have, of course, today mostly of the mounts are go-to and have the possibility of searching different objects in the sky, and tracking only using a cell phone, where you can find different objects in the sky. Let me try if I can put M4 in the field.
Okay.
This is very interesting cluster. I think that is, let me, I need to think that is upper under left, I think. If somebody can, but this is the referred source is an opposite. If not, it's great only for to make a little fly by the sky in this area. This is very rich. Maybe Nico that have a go-to software in their brain, can you guide me?
You need to use your hands, Cesar.
Yes, but I don't. Yes, sorry, I have this. But this is something that, yes, as say Nico, it's a pocket telescope.
Yes,
you know.
You have a great resolution. There is a really nice field of view.
Yes. Yes, I'm using. You can see some clouds crossing the field of view.
Yes. It's going across fast.
Yes, and this area is full of open asterism and full of open clusters. I don't know if sorry.
I think you got M4 down there.
Down there. I think that not here, if not in the opposite. It's something that it's fun. Well, with the Dobson, you make this. You make the same, but visually.
Yes, the star jumping.
Yeah, this is an star. Absolutely, a star jumping. But visually, I can make nothing tonight by the finder of the telescope, because it's really cloudy. It's something that sometimes the people tell me, do you have telescope for cloudy nights? And maybe this is a telescope, a system for cloudy nights, because we are watching stars and you can see the clouds.
Well, you know, there are many people who do shoot between clouds, you know, and
yes.
For instance, a lot of the astrophotographers in Britain, England, they get a lot of cloudy nights, you know, and so guys like Gary Palmer, you know, he'll be out there waiting for, you know, a hole in the sky, you know, to shoot in there for a little while, collect some data, and then, you know, so with the advent of tracking and stacking, you know, you can do some amazing stuff and still get data, you know, versus the old film days of taking a long continuous exposure.
Yes, there actually we are feeling more British people in Buenos Aires, because we are not lucky with the sky in the last time. You know that Nico and Maxi and me only, we are lucky to have in the last weeks. Maybe we have, I don't know, Nico, maybe four
Yes,
nights.
three or 4 nights.
Four nights only. Yes.
The weather was really bad here.
Yes. Yes. You can suffer with us, Scott. You can see the clouds. Yeah.
We get plenty of clouds here in Arkansas too.
Is
so.
to share the clouds.
Yes, yes. I
So,
return
it's
to
all part of the
Antares.
universe, right? So,
Yes, yes. But I think that this is so you know, make this kind of traveling by the sky, by the tapiz del cielo in Spanish, but the title of tonight global star party is something that you can enjoy and really is full of magic. You can, you know, maybe you stop in a part of the sky, and this is the same when you put your you know, where you can see more stars everywhere. Everywhere is full of stars, and we are watching in, you know, in a cloudy night, in a cloudy sky.
yes.
It's incredible. It's something that here's I don't remember the name of this cluster. Here we have a cluster,
I
maybe it's
see it.
M4. Yes,
Yeah,
yes.
up
Let
at the
me.
top there.
We can. Yes, if you like, we can. I'll center. Yes, I'm centering. I think that this is M4, and this is an opposite because, you know, Nico, maybe I think that.
Yes, that is
I searching in the opposite. Yes, yes.
You have that 3 stars down that when you see on the telescope, we see it up with the head down, and that are the 3 stars that I used to find that.
Yes,
You
yes.
see it.
Now we have the cluster. Beautiful cluster. M4.
Yes. M4 for sure.
Yes. Let me.
We can see it in the northern hemisphere as well. No problem.
Yes, yes, yes. I can use more gain with the CCD because it's full of clouds. But we can expect a small open small open clear sky, you know. Oh my God. It's not easy tonight, but well, okay, it's part of the fun, you know. It's a cluster with a very different
look at all the colors.
Color stars. Yes, yes.
Yes.
Despite the cloudy night, you can see different colors.
Yes.
Sorry by the audience about the situation, but sometimes I prefer show more things in a live image, in a live situation.
Yes, sure.
That is it's magic because it's something that have the magic, the more similar to show. Sorry, but oh my God, look the clouds. But you can see in both the scale, in the sky now, and you know,
right.
Look that, yes, yes. This was something that we was expecting because it's our clouds moving from in this moment are moving from the west. Exactly from the west, but because here you have the south and you can see and a small movement.
Yes.
Yes, coming from the west. You know, it's and something that I have. I can show you something that I took earlier, a video. Let me to show something that, much better than only clouds. I can show you quickly. Let me show you video from tonight. And how I can, let me share. Okay, here. You can see.
Oh, yeah.
It's a video that I took. Well, I have a video that I can process later.
Sure.
Well, this I took this image of this video of the moon here, and I took. You can see the moon.
Yes.
Okay, the video. This one is for processing a picture because I don't have Saturn or Jupiter in my field of view. And I took a lot of short lights of Centaurus A, another object that I can show you next week, but processing, of course.
Okay. Thank you, Cesar.
No, it's a pleasure. Here I can
you.
show you completely the equipment, the mount, and complete the telescope, you know. And here I can show you.
Very portable little setup. Very nice.
Absolutely. Yes, yes. And I use only a cell phone. It's not a new cell phone. It's a regular one.
Yeah.
And I can show you how I can move the telescope and use, for example, the settings. I can parking.
Yes.
It's a very portable and very easy to mount and use
Yes, yes.
It's great.
Really, really is something that I love. I love using this because my back is without pain. It's very important, and you know, it's something that really I enjoy. Have something that I put from the living room to the balcony, completely assembled, and only
I see. You just pick it
I
up
only
and move it
plug.
out. I see.
Sure. Only I plug the. I unplug only the connections and nothing more.
Right.
It's really for enjoying. Okay.
Thank you so much, man.
Thank you.
All right.
Good night to everyone.
Good night. Okay. Well, up next, and our final presenter is Ron Breacher. I met Ron at the Northeast Astronomy Forum. He is a very friendly guy and very accomplished astrophotographer. And and he's also a musician. So he checks off all the boxes as far as guys that should be going to Starmus, which I hope that he is able to attend the next one that comes up here. So, Ron, I'm going to turn this over to you. Thanks for coming on to Global Star Party.
Oh, this is fun for me. Thank you very much for having me. And I'm just going to share my screen with you. And Scott, can you just confirm that you see my screen?
Absolutely. Yeah, looks
Awesome.
good. Looks
Okay,
great.
so my talk is called Promises, and it's about getting good results with a new scope. And the title actually came from the notion of that feeling of promise that we all feel when we get a new telescope or any new amazing toy. But we're here for astronomy, so the toys that we get are telescopes and cameras and things like that. But that promise of a new telescope doesn't always match with the reality right away. And I kind of put this talk together for beginners who might be getting a new telescope. And for another reason as well, my wife always says I need to write down all the problems that I run into as I go through my astronomy journey so that I can help other people avoid them. And one of the ways I write them down is by putting them into slideshows. And so this just seemed really opportune. So I'm going to talk to you today about the promise of a new scope I've just finished setting up. It's a C14, so a 14-inch Schmidt-Cassegrain Edge HD by Celestron. And I want to talk a little bit about data acquisition challenges in general, but then specifically some of the ones that we all need to deal with and that I had to deal with, and then show you how the promise of this scope seems to be fulfilled. So this is me standing with this gigantic scope. Now, I've used a lot of scopes in my time. This Paramount MX that's carrying everything will hold 90 pounds. So my last setup was a 6-inch refractor and a 4-inch refractor together. And I've given a talk showing some photos from that setup. But this is the new setup. So just to summarize, the main new stuff is the 14-inch telescope. And Celestron also provided a dew shield, a dew heater ring, which is right on the corrector plate, and a controller for that, and a focal reducer. Prima Luce Lab threw in a low profile Asato focuser and an Arco rotator, and the Eagle Pro computer is sitting up on the top of the telescope. You can see it, it's the little red box. I'm using a QHY 600 mono camera, filter wheel, and off-axis guider. I'm not really going to talk about those much because I've been using them for years, so their promise is already known. I know they work well. Same with the Optolong filters and same with the Paramount. So the focus really is going to be on the big new tube. So this is sort of a laundry list of data acquisition challenges we all face all the time. Framing the target, we have to deal with light pollution. But really, when you're setting up a new piece of equipment, the challenge is just getting small round stars. And really that depends on the optics, the mount, the setup, where you're shooting in the sky. And you really want to solve this problem of getting small round stars before you go too far gathering data to make pretty pictures. Otherwise, you're never going to be happy with the stars. This is the kind of star image that we aspire to. Small, round stars, nice diffraction spikes if that's appropriate. Unfortunately, this is what we may get. Fat, bloated, out of focus stars. Or I call this nose and foot doubles. This is where you were guiding by hand and your nose bumped the guide scope.
I have one of those.
Yeah, anybody who's guided by hand has had a nose and foot double before.
Yep.
And then this is just like oblong, eggy, nasty looking stars. And so the main things that affect that are in two categories, mechanical and optical. We need good polar alignment and good balance on the mechanical side. On the optical side, you have to collimate. If your optics are misaligned, your stars won't ever look good. Focusing, of course, bloats the stars and reduces detail if you're out of focus. And optical aberrations are important too. We're going to talk a lot about that in a minute. Corner stars are usually most affected, but I had another interesting challenge with this new telescope. So if you're not experienced with polar alignment, I wanted to include some fairly technical stuff because I know these videos are available after the fact, and you can stop and look at this slide for as long as you need to understand it. But this really shows what polar alignment is. It's where the axis of rotation of the telescope, the right ascension axis, is lined up with the Earth's axis of rotation. So your mount is like a big clock going in the opposite direction to the Earth. So the question then, sorry to scare you with the math, you don't actually have to do the math again, I just wanted to include it. The real question is, how good does your polar alignment have to be for the telescope that you're using? And it turns out it depends on how long a star trail you're willing to accept, where the target is in the sky, how long your exposures are, the focal length of your telescope, of course. Long focal lengths are much less forgiving, and this is a very long focal length telescope, and the angle between your guide star and the object. And I just solved that for my telescope. So I'm binning my pixels, 7.5 microns, and I've just plugged in the numbers, and I only needed to be within about 1.5 arc seconds of perfect polar alignment. And that's not that hard to do. That's with a 3,900 focal length telescope. If you're using 480 millimeters or 600 millimeters, you don't need really to be that perfectly polar aligned. You can still get nice stars. There's a lot of ways to polar align. You can buy hardware like the QHY Polemaster. You can use through the mount polar scope like I have on my EQ6, or you can use software like you see in the window on the right, and that's the method I use with my power mount. Bottom line, just get polar aligned as well as you can. Try to get an accuracy of 2 or 3 arc minutes. And, you know, good enough is good enough. Sometimes the enemy of good is better. A little bit of misalignment in the deck axis can actually make guiding a bit easier, because your corrections are always going to be in the same direction. And if you do see some trailing that you don't like, shorten your subs or do a better polar alignment. Okay, payload balance. There's backlash in most mounts, not all mounts, but that can cause uneven tracking and elongated or double stars. You really need to balance in both axes, and there is a proper way to do this that seems to work better than any other way. First of all, you want to remember to balance the deck axis first. I'm going to show you how to do that. And remember to take off your lens caps, connect all your cables, make sure the scope is exactly the way you're going to use it. If you have some backlash in your mount, make the east side slightly heavy. That will make sure that you're always lifting. The gears are always lifting the telescope, and it will smooth out the guiding. Okay, so I said I was going to show you how to do the deck axis first. So the first thing you want to do is put the equipment like I've shown it here, so that the counterweights are sticking out to the side and the tube is level. Then unlock the declination axis and balance in deck. That's the far right. So you'll be tipping the tube up and down. Do that first. When you get it perfectly balanced by moving the weight forward or back in the saddle, lock the deck axis. Then you repeat that for the counterweights, the right ascension axis, which is the, well, you can see the counterweights. Remember, it's really important to take off the lens cap, have your dew straps on, have all your wires connected. Okay, collimation, it was really, it was pretty easy for me to balance my payload. No trouble there. Collimation, polar alignment was easy too. Collimation, that was a little harder. So first of all, what is collimation? Well, it's the alignment. It's making sure that the telescope's optics and mechanical axis are perfectly aligned, so that the maximum brightness of the light hits the center of the field on axis. It affects detail and star shapes. The faster the scope, the more sensitive to miscollimation. The scope I'm using is f11 with a reducer, it's f7.7. Not all that sensitive to miscollimation. Because it's a reflector, I'm going to have to get used to the fact that I might need to collimate it regularly. My refractors never needed collimation. Mac Cassegrains are the same. They generally just don't need adjustment. So in a Schmidt-Cassegrain telescope, which is what I'm using, a perfectly collimated out of focus star looks like the image on the right. So it's kind of like a donut. The hole is perfectly centered there. Whereas if you look at the image on the left, that shows an out of collimation star. And I actually took a picture of an out of focus star here. You can see it's very jaggedy and so on, but it's very well collimated. So that's what you want to do. You want to adjust the secondary. There's 3 little screws. You just turn by a very small amount and get good collimation. Very, very important. I haven't collimated this scope yet because it looked so good. I'm going to tweak it maybe when the moon is full. But for now, it's good enough to use. Focusing, of course, is important. You can do that manually using a Bahtinov mask. As you move in or out of focus, this center spike will move from left to right or right to left. The mask looks like this image on the left. You put it in front of the aperture, and here's a little animation of a star out of focus through a mask and coming into focus. And back. There you go. You have to focus regularly when you change filters or when the temperature drops. I use an electronic focuser, so you can get an add-on. In this case, I'm using a Prima Luce Lab Sato focuser. And I didn't have any trouble with that either, so I'm not going to talk about that too much. Optical aberrations. So that's basically, that can be due to the shape of the glass, or how it's positioned in the tube, or how things are connected to each other. And if all the optics aren't perfectly square to each other, the quality of focus isn't going to be the same everywhere in the image. So you might focus in one part of the image and have the rest look terrible. Some common causes that can put things out of square, camera at the end of the train that's so heavy that it makes the focuser sag. So you need a really well-designed focuser. Sometimes the sensor is not properly square inside the camera. That's a tougher problem to fix. You'd probably have to go back to the manufacturer. Oftentimes there's an optical defect, and that can be just related to how the mirrors or lenses are aligned or collimated. And so this is what I saw when I took my first images with this scope. You can see there's some really nice stars on the left. The ring nebula is well resolved. But if you look at the right side of the image, there's kind of fat, elongated stars that just turn into streaks on the right-hand side. And I tried to collimate this, and I just was not successful. I couldn't. It looks like a collimation problem, but since I couldn't collimate it, I reasoned it was some kind of a tilt problem, and I started worrying about my camera. It turns out it wasn't the camera at all. It was a misaligned lens in the focal reducer. It's going to be replaced, and I should say, I don't care which brand of equipment you use. It doesn't matter which scope, which reducer, which camera you use. They all occasionally have problems. So the question for me is not whether your equipment will ever have a problem. It's how will the vendor, how will the manufacturer help you resolve the problem?
That's
and
right.
Celestron was outstanding. I contacted their technical support manager, their technical manager, Chris Hendren, and he told me that he thought it looked like a misaligned optic in the reducer. He gave me an experiment that he wanted me to do. I did the experiment, we confirmed it, and a new reducer is on its way to me and will be back in the optical train eventually. So, and that's, you know, that's not my first good experience with Celestron. My first real telescope was a Celestron, and I've had nothing but positive experiences with those
That's
scopes.
great.
Here's another weird one. This is an unusual but equally annoying cause of optical aberrations. They gave me a do ring and I was putting too much power to it. I'm a manual reader, but one of the technical guys at Celestron asked me whether I had read a certain part of the manual, and I had to admit that I had not. I was putting too much power to the dew heater. The glass was getting too hot and giving me these crazy spikes on all my stars. So it took about a month to diagnose all of that, but here the promise is fulfilled. I want to show you 3 images taken in the last week with this telescope that's just operating beautifully right now. So this is the Ring Nebula and a beautiful nearby 15th magnitude spiral galaxy.
Beautiful.
This is the ET cluster, the Owl cluster, sharp NGC 457, and look at the beautiful colors in those stars. I hope it comes across well.
Yes.
In what you see on Zoom. And my favorite of all, and this was really the real first light image, is the Crescent Nebula that I had on the title slide. So I guess my message to folks is when you get your new stuff and you've got all that excitement and that promise, don't get frustrated if you have a little bit of trouble getting things going. Look for the obvious, look for the not so obvious. Don't be afraid to contact technical support to get the help you need, and you will have the promise of your new equipment fulfilled. And Scott, thank you very much for having me here tonight.
Thank you so much, Ron. Thank you. Beautiful images. This image, I think I just saw on Facebook today. Is that right?
Yeah, I just posted it. It was my first light image with the scope, and this is under 10 hours. And I should say, this was shot without the focal reducer. That's why the stars look so nice. The new one will go in when it arrives.
Terrific. That's great. I love to hear the success stories, but I also love to hear, you know, when you know, people what people do when things go wrong. You know, so. And
well, sometimes I go get a beer, but usually I doubt myself. You know, I doubt myself. I think I've done something wrong.
Oh, like you've done something wrong.
Yeah,
I find that's usually not the case with pretty experienced amateur astronomers. You know, I tend to, you know, I mean, being on this side of manufacturing and everything, I tend to look first at the equipment, and because you know, I've been doing this for a long time. I've been selling telescopes, retail, or, you know, working for the manufacturing side since 1980, and I've seen everything go wrong, just as you say, you know, with all brands of equipment.
Yeah.
So,
and you know, these are complicated systems.
yes,
most of us use multiple different brands that all have to play nice together. Thank you, Bob Denny, for Ascom and Alpaca, and you know,
sure,
all that good stuff.
not only from the software side, but the hardware side and the different objects, and it's complex, and it's a really interesting puzzle to put together. It's a big part of this hobby is to do that, and then once you have it really playing nicely, it's a feeling of great accomplishment, I think.
It
so.
really is. And the main thing I've always found out, because I've had issues setting up every system I've set up. They're all different, but it takes a while, you know. Don't be afraid to call technical support. Like, really get to know them.
Right.
Right, because they really want to help, and they will help.
Sure they will. Sure.
Yeah.
Norm Hughes is chiming in here. He says, when I got my new setup, I was so excited. I played for 6 months before I even checked collimation, polar, etc. I was just happy to be able to do this stuff. Finally, I said enough and fixed it. So
Yeah, so if you've got a system that's performing well, wait for a full moon or a mediocre night to check collimation,
right.
or to tweak it at least. If collimation is acceptable, but maybe you can get it better, don't give up a good night for that.
Right. Excellent. Ron, thank you so much.
Thanks for having me.
All right. And I want to thank our audience for being hanging in there with us through the night. And we'll have more Global Star Party coming starting next Tuesday. So look for our announcements. And if any of you out there would like to participate on Global Star Party, please get in touch with me here at Explore Scientific. My email is easy. It's just the letter S at explorescientific.com. So anyways, good night, and keep doing what my friend Jack Horkheimer always used to say, is to keep looking up. Good night. Thanks again.
At first glance, this single bright source, this smudge, this grouping doesn't look like much. Images like these are translated for our eyes, and it's because our eyes only can perceive a small region of all the frequencies of light. Astrophysics is much more than just capturing different wavelengths of light. Many objects or phenomenon are simply too far away to directly image. A lot of data comes from pixel-sized point sources, and those points provide astrophysicists with a powerful window into what makes up the universe. Even now, most of what scientists learn about the cosmos comes from studying light. Astronomers can work out distances, speeds, sizes, temperatures, and the composition of elements because matter behaves in predictable and consistent ways. They do this by literally prying these photons apart. This is spectroscopy. Explained. Spectroscopy is the study of how matter interacts with light. And it all began with a prism, like this one. Light entering one side of the prism bends or refracts as it passes through the triangle shape and exits out the other side. All of the wavelengths enter together, but they exit as a rainbow-like spread of colors. What's happening is that the shorter, more energetic wavelengths, like blue and violet, bend a little more than the longer, lower energy light, like red and orange. Because they bend at slightly different angles, the wavelengths separate, fanning out into a band of colors. NASA has a whole fleet of telescopes that can split and study a wide range of light on the electromagnetic spectrum, not just the light that our eyes can detect. So Hubble can detect through the visible spectrum, but also a bit into the infrared and the ultraviolet. Webb is just infrared and can look at the light that is emitted from billions of years ago. And of course, the images from Webb are really spectacular, but this is what flutters the hearts of scientists. This spectrum shows the light that penetrated the atmosphere of a planet called WASP 96b. The light being measured comes from the planet's host star, some of which skims through the atmosphere. Humans are a long way from directly imaging exoplanets, so telescopes like Webb will use spectroscopy to find those chemicals that could support life in their atmospheres. Which is why Webb's first spectra is so amazing.
You're actually seeing bumps and wiggles that indicate the presence of water vapor in the atmosphere of this exoplanet.
Incredible. But it's one thing to identify single elements or simple molecules, but deciphering whole foreign bodies like Dr. Owajawek.
Here
How
again,
do you
I
know?
zoom- Oh my God, it took us a very long time to figure this out. It really took us many, many decades, and it took us many, many fantastic new instruments.
If all of our astrophysical objects or anything that we're looking at were made up of one element, this would just be so easy. But we don't. So we have to do experiments on Earth like this to prove what we're looking at looks like what we are thinking we're looking at. So in here is argon. If we turn it on here, it glows this really pretty purple. And then if we look at it with a spectroscope, it shows us a very specific fingerprint to argon. These are called spectral tubes. My bounty of tubes. They contain the gas of one element, and the box runs a voltage through the tube. When I turn on the switch, the charged gas turns to plasma and emits a color that is unique to that one element. It also makes unique lines when you look through the spectroscope. And this one is helium. This same process happens in a star or a hot region of gas. So we use tubes like this to verify what we see in space. If you do a quick search for spectroscopy data, there are numerous ways that the data can appear. Those variations are based on the source of the cosmic light. There are 3 types of spectra that we can use: continuous, emission, and absorption. Light from a hot, dense source, like the sun, produces a continuous spectrum. When that light passes through cooler gases on its way to us, the gases take away or absorb some of that energy. Dark lines appear where specific colors are missing. And when thin gases glow themselves, we see only their characteristic colors, kind of like a cosmic barcode. These are the emission spectra from pure elements that were given a voltage to glow, just like my spectrotube, but way better. Like all data, there is an art to analyzing spectra. Scientists like Dr. Owajawek use computers to calculate and tease out clear signals, comparing them then to models that are already known.
There you go.
Many scientists in the labs on Earth, they try to recreate the same conditions and measure basically what these kind of, as you said, fingerprints of those different transitions for different elements are.
Okay, so we're always comparing to sort of the fingerprint of what we have, and then if it has deviated from that, that is the new information from what we're looking at.
Correct.
For Anna, spectra unveil the structures of black holes, the swirling winds that surround them, and those big jets of particles that come out of them. When you look at a black hole,
yes,
this is what you see.
Yes.
Where's the accretion disk? Where are the winds?
So all of this is mostly accretion disk at this level. It's just different parts of it. We can zoom in, right? And we see all of the absorption lines, right? All of these lines are also shifted a lot. So they come from this wind that we saw in the first picture. So that's how we know that there is winds blowing around black holes.
The same principles apply no matter the wavelength of light. But each wavelength of light tells us a little something different about each character we find in the universe. It's pretty wild how different the universe looks to our eyes and how it presents to our telescopes. And that's precisely why we need to observe in different wavelengths of light. Modern astronomy is built upon spectroscopy. So with every stream of light we gather, we further understand what the universe is made of. All we need to do is pry open its contents.
So it's a beautiful sunny day, and we have a refractor out, and I've got my Eclipse glasses on, and I've got my safe solar filter. Of course, the Eclipse is not here yet, but I wanted to take a few minutes just to show you some things about solar filter safety. The filters that we use is the highest ISO standards, and actually independently tested by us as well. So just to make sure that those standards are met. So if you're going to use a telescope to look at the partial phases, and let me underline partial phases to you. You use Eclipse glasses to observe the sun in partial phases when it's in total. If you're going to be on the path of totality, you can take the glasses off, and only during that time can you directly look up at where the sun is, because it's completely blocked out. You'll see the corona, you'll see, lots of really cool effects that they'll leave you speechless. But during all the partial phases, you have to have safe solar filtration. So how do you do it properly? Let me show you. First off, let's show you what you shouldn't do. What you shouldn't do is put on Eclipse glasses and look through the telescope that's unfiltered. And I'll show you exactly why here. We're going to point the telescope directly at the sun. And right now, we have sunlight coming right through the eyepiece. I can turn that up a little bit. If you use solar glasses and look right at the filter material, you see it's already burning. It's burning a hole right through the solar filter material. That is how powerful a telescope is. You can now see that there is a hole through there, and that could be your eye. So this is what can happen if you think that you can use Eclipse glasses to look through unfiltered telescopes or binoculars. If you do that, the sun's energy is going to burn right through the filter and burn right into your eye. So if you're going to use a telescope or a pair of binoculars to watch the partial phases of a total eclipse, or just to observe the sun to look for sunspots or something like that, make sure that you are using an over-the-lens solar filter that has the proper ISO safety rating and all of that. And so what I'm going to do is I'm going to put this filter on. It's you can see how snugly it's fitting here. This is not about to come off, but if you have a loose fitting filter, use tape. Do anything that you can to make sure that the filter is not going to come off. And then the other thing is too is that finder scopes, optical finder scopes are like little telescopes, and they need to be filtered as well. In this case, I just have a red dot finder. There is no magnifying power to it, so I'm not going to use it to sight the sun in. The way I'm going to sight in the sun is literally I'm going to look down at the shadow and align the scope up so I'm getting the smallest shadow possible of the telescope as it's hitting the ground. And now I can safely look at the sun in comfort and look at sunspots, and if we have partial phases going on in the eclipse, I'll see them all.
Are your Eclipse glasses safe for looking at the sun? Let's check to see if your Eclipse glasses can handle the heat or if they need to stay inside. First off, never check your Eclipse glasses with the sun. That's a good way to injure your eyes. Take your Eclipse glasses and find a bright light, like a lamp or a flashlight. Hold your Eclipse glasses up to the light and look through them. The light will appear extremely dim or not appear at all when looking through the glasses. For example, you should only be able to see the filament of a light bulb, but not the glow surrounding the bulb. Also, if your Eclipse glasses have any marks or scratches on them, don't use them. If you have older Eclipse glasses from a previous eclipse, give them a check to make sure they haven't been damaged or scratched. All safe Eclipse glasses will meet the ISO 12312-2 standard. It's best to store Eclipse glasses in a safe place where they won't become scratched or punctured. Remember, never look at the sun without Eclipse glasses or a solar filter. Be safe and happy sun viewing, everyone. you.